SolidWorks user groups got their start in 1997, created by users to learn from each other, provide networking opportunities, share their tips and tricks, and more.
The first time I attended a SolidWorks user group meeting was in about 2005. But what makes me keep coming back to these is that you're trying to learn new techniques, and there's a lot of minutia and detail that you're not going to learn on your own. So if you can talk to other users, it's very helpful.
The one thing that stands the user group apart, I think, above anything, is the community and the camaraderie and the people involved, and how being involved can get you further professionally and personally.
Being a SolidWorks Users Group member has benefited me professionally. I always enjoy tips and tricks. I've been going to SolidWorks Users Group since '06. I will see one or two every time I go to a presentation that I didn't know existed, or that it's a better way to do something that I've been doing for years. I have met colleagues, which is very important. I've met suppliers, and finally, I've met potential customers for over 10 years at Users Group meetings.
I am honored to be part of this community. I have for years, and if you aren't, you should be part of the SolidWorks User Group Network.
It gives you tips, tricks, and shortcuts you will not find in formal training. It's awesome, and it's free.
It's a fun environment. Everybody gets to know everybody. You get to learn. It's kind of free learning. It's great networking. It allows you to learn from the experts around. I do a lot of presenting as well, so it forces me to learn, so I'm an expert on the topic before I get up there. So all the way around, it lets me be a better SolidWorks user.
To learn more and join the best user community around, visit SLUGME.org and join a SolidWorks user group today.
All right. What is up, everybody? Welcome to the 5th annual SolidWorks largest user group meeting ever, also known as SLUGME 5. My name is Cam Smith. I'm going to be your host today, or tonight, depending on where you live. So I'll jump right off the bat and go ahead and thank our sponsors for SLUGME 5. Each of them has graciously offered their support and provided us with some giveaways. To have a little fun with the giveaway process, we're going to see who's paying attention tonight. In order to be entered to win, you need to take a 10-question pop quiz, and every correct answer will enter you with a chance to win. So the quiz questions are available in the handout section of this webinar, or if you're doing the multiple device thing and want to do it somewhere else, I am also posting in the chat. Everybody should have a link to the forum post for SLUGME. If you scroll down, the quiz questions are one of the first comments, one of the only comments. Once you have enjoyed your evening tonight and answered all your questions, I want you to email those questions to us here. That's our SLUGME email address. So the winners are going to be chosen at random after all the correct answers are put in a hat, and you're going to get notified. I'll respond to your email with a request for your shipping address. Please do not include your shipping address until I ask for it. So this year's, okay, let's go back. There we go. This year's SLUGME presenters are Ed Eaton and Eric Beatty. And they've got 2 presentations that are packed with valuable tips, tricks, and time savers. I'm sure you'll want to revisit these later on. As such, we are recording SLUGME 5 so that you can focus on the content today, and then come back and watch it again later if you need a refresher, or you just want to know, how did he do that again? If you should have a question during the presentations, please use the Send Questions to Staff option in your chat. If you go to your chat in your control panel, down at the bottom, it will ask you who you want to send your chat to. There's a drop-down menu. Make sure you hit the Send Question to Staff in the chat, okay? Right, so if you should have a question during the presentations, and please use the send question to staff option in the chat. We will be monitoring the chat throughout. Also, please feel free to submit any SolidWorks questions that you have. There's going to be a specific Q&A session for each presentation with Ed and Eric following their presentations, but then there's going to be a special Stump the Chumps Q&A session at the end for all other questions. So, here we go again. Go back. In this slide, you can see at the bottom it says powered by SWGN. Well, what is SWGN exactly? SWGN is SolidWorks User Group Network, and swgn.org is our website. This is where you would go to find the user group closest to you, also where you would go to get help creating your own group. And I can attest to the fact this is actually a pretty easy process, and it's a lot of fun. So if you know somebody who's considering starting a user group, or if you know somebody who you think would be a really good user group leader, please send them to this website. Each region on these maps is represented by a SWGN committee member who runs a user group of their own within that region. And they also volunteer their time to help unify all of the disparate groups around the world into one cohesive network, SWGN. But one of the keys to a successful and cohesive SWGN is our relationship with SolidWorks. SolidWorks supports the SWGN in many ways, to include providing us with a direct liaison in the SWGN manager. Dan Wagner has recently taken over at SolidWorks as the SWGN manager and has been doing a fantastic job. I want to go ahead and bring Dan in now so he can introduce himself. Hey, Dan.
Thanks, Cam. I appreciate the intro. That was awesome. Thanks for having me. Well, I think once again, I just want to kind of welcome everybody to this awesome event. It's certainly been in the works for a while, and I've been pretty excited to be part of the team that's bringing it to you tonight. I'm into my second month here with SolidWorks as the manager of SWGN, and I've been around for a while though. I've spent about 12 years working in the reseller industry, doing tech support, teaching SolidWorks classes, doing sales presentations, doing the what's new presentations every year. So I certainly am familiar with the community, and I know the love everybody has for SolidWorks, and I certainly feel the same thing. This event too is pretty amazing tonight, Cam. Like if we look at this list, we took a pretty good list at the registrants for tonight. We have a lot of people that signed up and a lot of people that are signed in right now. Over 230 of those people are new people that maybe aren't already a member of SWGN, which is pretty cool.
Wow.
Like they're not a member of a particular group. And of the groups that we have with us tonight, there's over 100 individual groups, like members of individual groups throughout the world. So this image you're showing here, the reach that SWGN has, is awesome, man. And again, I'm just happy to be here. Thanks for having me.
Fantastic. Yeah, thank you. Thank you. And I can speak for the SWGN committee that we look forward to spending many years working with you.
Thank you. Appreciate it.
All right.
Hey, nice shirt, by the way.
Hey, thank you. We're already getting questions about the shirt, so we're going to have to cover that later on. Don't worry. Thanks, Dan. All right, so Dan touched on something. Stats. One of the common things with SLUGME every year is the fact that we're bringing together a really huge group of users from all over the world, virtually. But one of our favorite ways to really display that is to aggregate a little data. You know, how many combined years of experience do we have? How many certifications do we hold? How many user groups are represented, like he just said? And of course, the most important question that everyone always wants to know is how many pizzas did we eat? Well, I'm going to go ahead and I'm going to ask you guys a few poll questions, and then I'll share the results with you, and that'll produce our image to go in next year's presentation for all the stats. I'm only going to leave these polls up for like 30 seconds. There's a few of them. I want to knock through them real quick, so everybody please get ready. And I will give you this one note. If you are viewing this webinar in full screen mode, then you may have difficulty answering the poll. If you do, exit full screen, answer the poll, and then you can go back into full screen after we've done this portion. All right, I'm going to go ahead and launch the first poll. Boom. All right, everybody, what time of day is it where you are? So normally we would like to ask, what time zone you're in, what region you're in, but webinar poll questions being what they are, kind of have to limit the response, but this is, or the answers, but this is the way for us to find out how wide our reach is around the world for this presentation. And let's see, oh wow, we're 30 seconds into it. We got about 75% of everybody's voted, but the numbers are climbing really fast. So I'm gonna go let it go a little bit longer. We're already over 80%. And looks like we've stalled at 83%. All right, I'm gonna go ahead and close that. And I'm gonna share the results with you guys. And it looks like it's evening for most of us, afternoon for a good portion, but there's some really dedicated folks out there. Middle of the night, in the morning. Thank you. Thank you for being here with us. All right, I'm gonna go ahead and launch the next one. How many years have you been using SolidWorks? Now, this is gonna get us a ballpark figure because we had to do it in ranges, but this should give us a pretty good estimate of how many people have been using for how. Ooh, I'm liking these numbers. We've only got 10% of people voted so far. Vote quick. We're already at 30 seconds. Let's see. Looks like I'm right in the sweet spot with the majority. All right, I'm gonna give it about 5 more seconds. We're just over 80%, so we're getting about the same response from the first one. All right, here we go. 5, 4, 3, and we'll close that. And we'll share those results. Look at that. Oh, I misspoke. Look at that. I'm in the 6 to 10 year range. I'm at 10 years of experience, and the 16 to 20 bumped up right at the end. They came from behind. Man. So, but that 6% at less than a year, thank you. Thank you for finding us and connecting with us. This has been a tough less than a year to be a part of, and I'm glad that you're with us. All right. I think, yep. Those are the only 2 polls I'm going to do right now. So thank you, everybody, for answering those questions. Now I'm going to go ahead and introduce our first guest presenter, Mr. Eric Beatty. Not only is Eric one of the longest running continuous SolidWorks users in the world, having used the software every day of his professional life since March of '96, but Eric also essentially invented the SolidWorks user group when he founded the very first one, Seattle area SolidWorks Power User Group, the same year he started using the software in 1996, while he was teaching at North Seattle Community College. Eric is now a senior mechanical designer for Omax Corporation, a leading manufacturer of CNC abrasive water jets, which you may have seen spotlighted in the SolidWorks 2020 rollout. Eric is a certified SolidWorks expert and was recently honored to be included among the first group of SolidWorks user champions. Ladies and gentlemen, Mr. Eric Beatty. Hey, Eric.
Well, hey, Cam. Hey, Cam. Hey, folks. Thanks for those kind words and introductions. Golly, I'm just thrilled to be able to get a chance to spend time with all you folks. Before I get rolling, one thing I do want to say is that's a really nice shirt you got there, Cam and Dan and all the other fellas. And oh, hey, I got one too here. But what I really want to say is I want everybody to give a big virtual standing ovation to Cam and all the folks that are behind the scenes right now putting this event on for us all. I certainly know the effort it takes. Cam and I have switched roles this year. Last year I was the host and behind the scenes string puller, and Cam was one of the stars of the show. And gosh, I was trying to figure out just who has the more awesome person that they're serving as the opening act for. After all, I've got the Ed Eaton, and you had Lynn Vergatu. I'm going to have to say quite emphatically that I think we've got a dead heat tie right there in terms of the sheer awesomeness. So again, one more time, folks, for Cam and Dan and Ryan and Todd and all the folks back in the control booth. Thanks so much. Cam, I'm going to go ahead and can figure it out here. I'm gonna make myself presenter. Why don't you go ahead and make me presenter? I got such a low screen here. I'm not sure which one I want.
All right, I've got two versions of you, one organizer, one panelist. I have to bump one up.
Go ahead. Let's start with the organizer one.
Okay.
Yep, that is it there. Let me pull off my audience view here, get that all dialed in. Let me go ahead and pick which screen I want. I believe I want monitor 3. There we go. All righty. So again, a little bit, you'll see some of my background bio, but I'm going to lead off by saying I spent about 20 years in front of a classroom. And let me kill my webcam, save some bandwidth. So as I was saying, I spent about 20 years in front of a classroom, various locations all around this great nation, and as a result, I am not gonna, overwhelm you with some PowerPoint slides here. I'll just give you a couple, and then we're gonna launch right into the heart of the matter, because that's what we're here to see. We're here to see CAD stuff, not PowerPoint. Again, a little bit about me there. I think that's probably the most comprehensive bio that I could come up with myself. Just #1 SolidWorks fanboy. And in fact, about a year and a half ago, I had the great honor of speaking at SolidWorks headquarters in Waltham, and when I submitted my slides along with the bio slide, Karen Nader, who's Gianpaolo Bassi's power behind the throne, she said, "Eric, you need more of a bio slide than #1 SolidWorks fanboy." I said, "So well, Karen, maybe you could come up with something, because that's really all I ever think about myself." And so she did a little digging, and she managed to put together a pretty comprehensive one on me here. So again, Karen, I thank you for that. But again, for the past 14 years, I've been with Omax. Arguably, we're the world's leading manufacturer of abrasive water jet machines. Before that, for a dozen or so years, I was lead instructor at North Seattle Community College. In fact, that's where I first was introduced to SolidWorks. But I've been doing mechanical design since the mid 80s. Started off in 2D CAD, then in the mid 90s got into 3D CAD, discovered SolidWorks, and haven't had an unhappy day in those 24, it'll be 25 years in this January since I first saw SolidWorks demoed, and it'll be 25 years in March that I actually started using it. Cam mentioned, I founded SASPUG. April 2nd, 1996 was our very first meeting. We're the first SolidWorks user group. And over the years, I've racked up some SolidWorks certifications. And like I basically point out to folks, that just means I'm either, have a real fondness for taking tests or real penchant for passing tests, but I got me some certifications, and I've also had the great good fortune and honor to be among the inaugural group of SolidWorks champions starting back in June here. A little bit of background about what I'm going to talk about tonight, and then we'll get into the heart of the matter here. But I wear several hats at OMAX. I'm a mechanical designer. Because of my extensive teaching background, I do a lot of technical training there. I'm the CAD administrator, and I'm also one of the PDM administrators. So again, as you know, these new tools, the cloud CAD apps like XDesign, XShape, XSheet Metal, SolidWorks Connected have been introduced. It's really piqued my curiosity because, again, everything that those tools do are tied into, one of the roles that I have at OMAX. As part of my curiosity, the Instant X design was announced several years back at World. I don't think Gianpaolo Bassi had left the stage before I had the web page pulled up and signed up for it. And as a result, for almost 3 years now, I've been using X Design through its Lighthouse beta program, and my involvement has given me the opportunity to travel to Milan, Italy twice to participate in X Design hackathons there. And so, like I said, I'm always trying to find ways to leverage these new tools because, again, deep down, I'm probably the ultimate CAD nerd. And so, out of my own curiosity, out of my own time, I'm not getting paid for it or anything, I dreamed up a pilot project that I wanted to use to explore how we at OMAX could potentially leverage these new tools, how we could maybe, streamline some existing workflows, some processes we do, maybe open up new avenues for additional CAD users and possibly build some new workflows. So towards that, and my final slide before we go, quick agenda. I want to give you just a real high level look at some things about SolidWorks Connected, the newest offering. We'll take a look at how I envision. Again, remember these are my visions. These are my pipe dreams, or my fever dreams, if you will. But just take a look at using how we can use Connected alongside the desktop and PDM potentially. I want to show you some nifty X Design only capabilities that I'd love to see work its way into the desktop version. And then after about midway, I'm gonna switch computers. I'm on a desktop machine running SolidWorks Connected. I'm gonna switch over to my laptop running SolidWorks Desktop and connected to the 3D Experience platform. And again, we'll look at some X Design and how we can work back and forth. And I just got access this morning to XSheet Metal. And if we have time, hopefully I'll show you some of that stuff. So again, let's jump right into SolidWorks Connected here then. All righty. So again, just taking a quick high level look at SolidWorks Connected, probably the biggest difference visually is when we look at our background screen, there's not a year listed here. It just says SolidWorks. And up here, just says SolidWorks Connected. But other than that, as I look at it, we've got all our traditional stuff here. So again, if you've been using desktop for, a few months or a few years or a couple decades, it's SolidWorks. If you really want to find out what the differences are, then and I'm going to throw this link here in the chat, but here's a link to the web help version of SolidWorks Connected with basically the what's the rundown of what's the differences here in terms of functionality, things like the user interface, opening and saving files. And again, I think this right here is where things really really show what the differences are. In the desktop, we're opening stuff up from local disks or from a PDM server. In Connected, we are opening things either from a local disk or from our 3D Experience platform. In fact, I'm going to open up here the task pane and pin that into place here. But for you PDM users, you'll probably recognize that there's a similar pane in PDM here. And if I look at my file menu here, you'll see that I have an open and an open from PC, this PC. And similarly, I have a save. I don't have a save as. We'll talk about that in a little bit. I've got a save with options. That's tied into my cloud operations. And I have an export SolidWorks file. What the heck is that? Well, we'll talk about that in depth, hopefully, but it's basically, SolidWorks Connected keeps things in the cloud. It lives in the cloud, the files do. So if I want to get them back out of the cloud and onto a desktop machine or something, I'll be using it here. Okay. All righty. So again, let me go ahead and close this here. And let me bring up, well, actually, let me do this here first. I'm going to go ahead. I'm going to open up a file off my PC. And like I said, I'm running, SolidWorks PDM Pro alongside SolidWorks, Connected. And again, I've got PDM set up on this machine, so it's, I'm strictly in read-only mode, because on this machine, I'm assuming the role of a tool designer in our manufacturing department. And those fellas over in engineering, especially that Eric Beatty, he's real particular about folks messing with his models and everything. But again, as a tool designer, I might need to, possibly do some things, maybe add some stock, maybe make some tweaks or some fixturing holes or features for manufacturing the components. So I'm going to browse to that folder where Eric has this drive plate. And again, like I said, it's read only because, don't want those tooling guys messing with stuff here. So again, this has just come off my local disk, and I'm going to go ahead and I'm going to, slow down there. I'm going to go ahead and save it. And it's saving it up onto the 3D Experience platform. Notice, it's sending all this info to the server here. So I now have this file up on my platform. And again, just so we can take a peek here. I'm in my 3D Experience dashboard here, and I'm going to go ahead and I'm going to search on that part number. And again, you can see that I've got it stored up in there. Again, I've got the CAD family, and let me talk about that for a moment. There's a CAD family, which is the overall umbrella record. I hesitate to call them files because really it's database records as best as I understand it. But the CAD family is the overall umbrella record that houses everything, and then physical products are the actual model. They're the configurations. If you've got more than one configuration in a part model, you're going to have more than one physical product. And in this case, I've got my my default, and I've got this water jet configuration. Okay. So again, we've got them over there. Okay. Alrighty. So again, like I said, I don't have read access to this model the way I set up my PDM structure and my import structure. So as the tooling designer, what I'm going to do is I'm going to go ahead, I'm going to start a new model here. My mouse pad's a little sticky here, so you'll pardon my fumble fingers there. And I'm going to go ahead and insert that part right in there. Yep. Okay. Alrighty. And so there's my model in there, because again, as the manufacturing engineer, this particular part is almost 100%. Well, I shouldn't say 100%, but the bulk of it we can cut out on one of our water jet machines. But again, things like these counterbore and tapped holes and this bore here and this pocket, those aren't things that we'd want to or be able to water jet out necessarily. So probably what I'm going to do, and I won't take it all the way to completion in the interest of time here, but now that I've got this, I'm going to go ahead and save this. And I'm going to call this, WJ-326-123. So this is going to be my water jet part here. I'm ignoring the other fellow's water jet configuration because I saw what he did, and I don't disagree, or I don't agree with him. Okay, so now I've got my model here. So basically I'm using a derived part here. I'll point out over here in the PDM pane, or I shouldn't call it the PDM pane, the platform pane here for my 3D space here, that again, I've got the original model here. It's in a locked state, or it's not reserved, it's unreserved. Whereas the model that I've just created by inserting it, it's not been modified and it's reserved by me. I have the key to it, so I'm able to make modifications here. So again, just since we're talking about the this arena of data management. Again, let me show you as a tool designer or as a manufacturing engineer, my data management workflows are far less onerous, far less involved than the ones with my engineering counterparts. And so, for example, let me find that. You should be seeing here in a moment. This is a screenshot of the PDM workflows for a typical CAD file in OMAX here. Again, we've got where a CAD file enters in, a brand new file that comes in here, and we have this whole area for the processing of prototype or preliminary models. We have, things, a set of processes for models that have been, production released for their revision and control. We have workflow areas for what we call corrective editing. Something that, oh gosh, I misspelled the word on a drawing title block, but it's already been released. Well, in regular release fashion, if I didn't have that, I'd have to put it into a revised state to fix the title block, to check it out, and then set the revision back. We don't do that. And then we've got another area here for legacy models that were imported from a previous PDM system. So again, I look at this and I see our PDM workflows. You look at it and maybe you think that somebody dropped a big bowl of spaghetti on a sheet of paper and took a picture of it. In contrast, here's the stock out of the box workflow for managing models in the SolidWorks connected, cloud storage. We're using Innovia's collaborative lifecycle. I brought my model in. Initially, it comes in private, just like in PDM. The instant I save it, it's in a work process here. I can either skip this review or frozen state and release it, or I can bump it on through. So again, much more streamlined. I'm sure I could make it fancier, but there's no need in this case here. So again, coming back to my model, I could start making some modifications to it here. For example, and again, I won't go through the full process here. Using like my direct editing tools here. I can delete faces, I can remove them. In this case, I can split things if I've got multi-body. So again, everything that we're used to from desktop is all right there. I'm going to go ahead and move this face. Again, I'm going to offset it about 1/16 of an inch there. Put some more material in for when I water jet it, so I can perhaps, clean up that bore. Maybe I want to do some face deletes here. I've got this through hole here. I've got this through hole. Got this counter bore. Oops, I think I accidentally picked a wrong face there. And again, I'd keep stripping this thing down until, I had a model that, effectively represented the part blank as it comes out of the water jet machine here. And so, here, let me actually pull out one or two more faces here. Again, we'll pull these out. Pull these out here. Okay. And at this stage, I'm ready to, generate my tool path for this. Well, at Omax, we've actually got a nifty little macro for extracting a face for the DXF, which is the key file for water jet programming. And you may have heard that, SolidWorks Connected doesn't run add-ins or macros. Well, that's only a half truth, A lot of the add-ins are not supported, do not run in SolidWorks Connected, but our macros are here. And again, I'm going to go ahead. I'm just going to pick this face, and I'm going to browse to my menu here, or my macros. Okay, and at this end, it's totally done, but on my other monitor here, what happened is that the macro not only generated the DXF file, but it went ahead and exported it straight into our Omax software here. And I'm going to go ahead and generate the tool path here. And I'll leave and post-process it. Oops. Sorry about that. I'll go ahead, I'll post-process it. And I'll look it out. So it'll come in here, it'll pierce the material there, creep along, start cutting, trip around there, and then exit out. Travel its way from feature to feature. I'll go ahead and I'll save that. And again, I'll go ahead and I'm going to open that path up here. And I'm launching our other program, our machine control program called Make. I figured y'all would like to see this here. And this is an inch thick here. Sorry, it actually launched on my other screen here. Oh, here, tell you what, I'll go ahead, I'll bring this up on there. So y'all should be seeing this is so recall it's 1 inch thick aluminum. Got some here, yep. Aluminum 6061. I'll say okay. It's going to go ahead and calculate the time and everything. And so to cut this out as it stands there, it's about 8.5 minutes. And it'll use a few pounds of garnet, a little over 11 pounds of garnet there. So again, I've taken it all the way from the engineering model to a water jet blank to programmed it and done my job estimation there. Okay, I'll go ahead and close these out here. Boom. And I'll say, yeah, I'll go ahead and save that there. All righty. Okay, so I'm gonna go ahead and save this again. So again, hopefully that's one example of how we could potentially use it. Another example here, let me go ahead and bring this up. Is again, I've got a very large casting that I'm just designing some tooling for. And this is the tooling that's going to be bolted into that casting after some initial machining's been done. So it can be set up in a rotary fixture here. And again, this is the model of the casting. Again, the bulk of the features are on the exterior. There's a couple axes here. Let me go ahead and make those visible. And so again, these two axes pass right through the center of gravity of the raw casting, which you can see is, again, an inserted part. I'm a big fan of derived part for models like this. So again, there's the tooling I've designed, the fixtures, and that they are read-only right now, but I'm going to go ahead and reserve them. Nope. Just in the interest of time, I won't refresh that from the server. But again, I just wanted to point out, if you look at my feature tree here, again, these are a couple models I knocked out in about an hour. Just using some in-context features, some body move copy. Again, once the final tooling design is done, I'll probably go through and polish it up and remodel it properly. But again, this is just my concept. And so let me go ahead and unhide my design there. But again, I did just like I did earlier. I brought that model from our engineering PDM vault, brought it over into the 3D Experience platform and SolidWorks connected, and I inserted it in this tooling features model. So again, it's another derived part. And then I started building my fixtures model in it. And once I had that done, I used my fixtures model to create some assembly features. And here's another thing about SolidWorks Connected versus desktop. When you create a assembly feature in SolidWorks Connected, it automatically pushes that feature into the part or the parts, the models that are affected by it. So again, you'll see in my assembly here, I've got these two cut extrudes where I machine a small pocket or shallow pocket in each face to bolt that fixture to. And I throw in some tapped holes and some dowel holes. And I put a big old tapped hole here to screw a lifting lug into. And again, you see those features here. If we were to look at here we'll look at that feature, look at its feature scope there. Let it rebuild itself. Well, if we actually look at my part model here, again, you'll see that those features have been pushed down from the assembly into the model there. So again, another difference between how SolidWorks Connected and SolidWorks Desktop operates. So again, those are some of my really enjoyable aspects, or what I think are exciting about them, SolidWorks Connected versus the desktop. Again, I don't know if using it alongside PDM might be in like the doctor and pharmacist terms off-label, but again, that I see them working really well together. In my department, engineering, we need those complex workflows to manage things. On the other side, where it's manufacturing engineering, that maybe they don't have as stringent or as involved a design process, it doesn't make sense to set up separate workflows for them in PDM, and especially for casual PDM users. So again, that's some of the stuff that I'm envisioning, and I'd be eager to hear what folks think about that. Alrighty, so at this point, I'm gonna exit this computer because again, like I said, I've got regular SolidWorks and the X-Design apps over on my laptop because again, SolidWorks Connected does not run on or should not be run on the same computer as your desktop, and so I wanted to keep them separate there. Okay, so I am going to change presenter. I'm going to make my other computer the presenter. Okay, and now here I am. Hopefully y'all can hear me. That and can you see my screen are probably the two most famous phrases that are going to come out of 2020 here. Okay, well, sorry about that. Okay, so again,
You're good.
is my mic coming through, Cam?
Yep, you're all good.
All righty, thanks, folks. All righty, cool. Okie doke. So again, throw that up there. Okay, so like I said, I'm running SolidWorks Desktop here, 2020 on this particular machine. I'm going to turn the screen off. I'm sorry, I'm going to turn my camera off. So I'm running 2020 on here, and in this scenario, I'm supporting field service techs and engineering techs that don't necessarily have access to high-powered CAD workstations. They're probably using 4 or 5 year old laptops that can barely get out of their own way. So you know, as they travel around, get beat around and everything. So in this case, a cloud solution is probably a lot better. You know, with the 3D Experience platform, the cloud apps like XDesign, Xshape, XSheetMetal, they're all running on the 3D Experience platform servers, and your display, what you're seeing is delivered to whatever device you're using. A great example, anecdotally, is when I first started using XDesign and I was prepping for the Milan Hackathon 3 years ago, just to test out the range of devices, I was working on this laptop I'm currently on. It's a Dell Precision 7720. Got 64 gig of RAM. It's got a 12 gig video card. It's got fuel injection, big headers, dual Holley 4 barrels, whole 9 yards of nitrous. I was also using a 14-year-old Dell laptop that was still running Windows XP. I was using a Samsung Android phone, and I was using an Amazon 10-inch Fire tablet. And every single one of those, I was doing actual modeling on. I wasn't just viewing, I was modeling. I was adding fillets, I was making extrusions, I was doing sweeps and loss. So again, you know, the platform could run on just about anything. Sorry about this. I got to turn off a phone alarm. Okay. So just you know, take a peek here. So in this case, my customer service tech, my field tech, he calls me up and he says that he's gonna need to design a bracket that he can bolt to this extrusion and bolt to this face here. So to kind of steady that assembly while he takes it out and gets it packaged back up so he can ship it back. This customer has crashed their machine, and so rather than ship the whole thing back, we can actually remove the XYZ stage from it. This is our Protomax machine. You might remember seeing it 2 years ago on the shop floor at SolidWorks World 2018. So what I did was I did a pack and go, made a zip file, and here. And I put that zip file in my Google Drive. I could put it in a Google Drive, a Dropbox. There's a 3D Experience Drive you have access to. But basically, I've got just about all my cloud file services, you know, linked to it. And so I went ahead and I put that in there. Back, I think we can take a peek at it here. Oh, yeah. There it is. So there's my zip file. I went ahead and uploaded it to there. And I brought it into XDesign. I'll show you some really nifty stuff about XDesign in a moment, but I just want to show you this first here. But basically, if I want to bring a SolidWorks assembly into XDesign, I want to import it there. There's a couple ways that I could I can bring various, CAD files in there. But the two best ways for bringing a SolidWorks assembly in, if someone ever asks you on a quiz or something, is you can have the assembly file and of course all its requisite parts there, or you can use a zip file from a pack and go, and that's exactly what I did here. So I imported it and I started doing some stuff, and I started building an X sheet metal part a little bit ago this morning. And again, if time permits, we'll go ahead and we'll take a look at that. But first, let me show you a little bit about X design here for those of you that might not be familiar with it. Essentially, X design is just like SolidWorks. 3D CAD modeling, it does parts, it does sketches, it does assemblies, it does multi-bodies, and it all happens on the cloud, displaying on whatever screen you're viewing it on, and it also stores everything on the cloud. It's based on the same geometry engine that powers CATIA, which I find especially exciting because it's gonna really really grow by leaps and bounds in capabilities over the coming years. But again, let me show you some of the stuff that as a desktop SolidWorks user, I find really appealing about it. I mean, right off the bat, you recognize the interface. I've got my design manager area here, my graphics area, and down here is my action bar, very analogous to our command manager tabs. Okay. We've got keyboard shortcuts. I hit the S key. And it brings up, I'm gonna go ahead and I'm gonna edit this sketch here. Okay. And now here's some of the stuff that I really dig, just in terms of sketching. You might think, woohoo, sketching, how can that be exciting? Well, you may or may not know that oftentimes, or of late, I should say, some features, they actually start out here in X Design where they can try it out, and then it migrates to the desktop SolidWorks, and sometimes vice versa. I mean, for several years in SolidWorks now, we've had the ability that with my trim tool, if I just kind of drag along, it'll go ahead and trim stuff off there. That's pretty nifty, I'd say so. Well, X Design does it too. And here's something X Design does that SolidWorks Sketcher won't. I'm gonna start my fillet tool. And I'm just gonna drag across there. And look at that. It just automatically, created those sketch fillets. Now, how did it arrive at 21 millimeters? Well, it's all I kind of dragged across a big chunk, so it says Eric probably wants a larger radius there. And then it goes ahead and creates equal radius relation or equal radius constraints to everything there. Now, what if I were to come down here? Again, it still creates the same size. Why is that? Well, again, I still have that fillet command running. If I go ahead and turn it off and turn it back on again, now it's made some tinier radii there. So again, that's something pretty nifty that I really like there. Making a lot of fillets, just boom, boom, boom. Okay. Alrighty. I see my friend Cam has popped up to remind me that I am such a long-winded talker here that that I get to having fun, and I have too much. I could just show you stuff
It's
all
such
night here.
good
Hey Cam,
stuff.
can I have a couple minutes just to show them one more
Absolutely.
thing?
Please do.
All righty. Okie dokie. I think this is probably one of the most nifty aspects. I'm going to go ahead and close this here. And I'm going to bring this model up. And as we know, in SolidWorks, we have now, within the past couple releases, we have the ability to, take a chamfer, turn it into a fillet, and vice versa. We have the ability to, using Instant 3D, I know Toby's on here and he's not a big fan, but with Instant 3D, I can grab a feature, and I can drag it down a little. And did you notice that it changed from an add to a cut here? Again, those are super features. And I'm gonna just go ahead and switch that back to an add there again. Flip the directions. Okay. Well, they're super features, is what they term them, but I think they're super duper features because if you look real carefully, not only can I change this from an add to a cut to creating a whole separate body, and I can, in one fell swoop, make it a solid, a thin feature, or a surface, but I could say, I don't want an extrude here. Maybe I want to revolve, or maybe I want to sweep. And so what I'll do here is I'll say, I'm actually going to use for my sweep path, I've got another sketch here. Let me show that sketch. And let's see here, let me go ahead and show that one as well, sketch 6. So again, for my sweep path, let me use this sketch here. Oops, got a little too fast on my clicking. And I think I'm getting a bit of a lag with and I'm going to go ahead and make that a solid cut instead. And so again, I've changed that boss extrude into a cut sweep there. And again, just
really cool.
one last thing here I'll show off and point out is that, again, with this super feature, the only thing it doesn't do is a loft. But again, boss sweep, boss extrude, boss revolve, cut sweep, cut extrude, cut revolve, surface sweep, surface extrude, surface revolve. It's better than a Ginsu knife. All righty. So again, I think there is just so much to be offered by these new cloud tools. And gosh, I didn't even get to show you some of the other stuff. So maybe we're going to have to do maybe a SLUGME 5.5 maybe in the spring or something, or hey, book me for a user group. I travel very far virtually.
There you go. We've got
right.
some questions that we can key up now, and any questions we don't get to could be saved to the end for the Stump the Chump session.
Oh, right on.
I
Fire
know
away.
there's a question in here that I know you have keyed up already, and it says, "Isn't there a cool sketch relation thing built into XDesign?"
Oh, by golly, by golly. Cam is playing to my ego here because this is actually a sketch tool, a sketch relation that I directly requested during the Lighthouse program. And my good friend Sal Lama, who I believe is in the audience, was happy enough to implement it for me after I told him my sob story. Quick background. 3 years ago, using XDesign, some of the model I was making had lots of holes in them. But there wasn't a hole wizard yet. And so I found myself sketching a lot of circles. I mean, a lot of circles. And then coming back and having to add lots of equal radius constraints here. Well, I just sketched a circle here. Let me zoom in a little tighter. And I could sketch another circle. And hey, notice that pink dashed circle that just appeared there. Well, again, it remembers the last circle I sketched. And if I drag my circle over to that, I have now created a whole bunch of circles that all have the same radius.
That's so cool.
And they are constrained to one another. But wait, there's more. What if I sketch a bunch of different ones? And now I realize, oh gosh, I need one of these again. Well, what I'm gonna do is I'm gonna drag my mouse over here, wait for it. See that circle appear? Mind equals blown.
Yes, that's awesome.
All right. What else we got there, Cam? What else do the folks want to know?
Let's see. I'm gonna scroll up. There's some good ones. Eric, how do you see companies being able to transition from traditional PDM to SolidWorks connected and Ovia based?
Oh gosh. Well, I think it depends on the situation. You know, I'm no deep thinker or business strategist or anything like that. So I'd have to, you know, defer to answering by my demo, you know, in the first half here. Again, at OMAX, we've got about 30 seats of SolidWorks, maybe in total about 40 some SolidWorks user, ranging from, you know, hardcore day in, day out to folks that, you know, pop in occasionally. We've got 30 seats of PDM that float around. And for us folks in engineering, we have very complex workflows. They've evolved from simpler ones as we've realized contingencies. And so it works for us. Now, on the other hand, as I looked at the you know, our manufacturing planning folks and tooling folks, I mean, they don't have near the complexity of design processes that we necessarily might. You know, they're usually on the receiving end. Oh, so, well, sorry, I should have been. So they're usually on the receiving end of our data, and so they're developing simple tools or fixtures, or in the case of like blank example, they're doing simple processing of materials and parts there. So, you know, I don't know how much of an answer that is, but I totally think there's room for everything in both. In large organizations. In small organizations, you know, connected might be the way to go. You know, maybe your workflows aren't as complex. You know, maybe you want the ability to, you know, manage files and versions and revisions without having to, you know, have a PDM administrator. And, you know, I've been doing PDM administration for about 3.5, 4 years now. And even after all this time, I joke that, you know, the deepest part of my knowledge is that I can spell PDM correctly. Everything else I'm digging in the manuals or calling Tom Cody or somebody.
Shout
So
out.
again, I don't know if that's an answer, but I hope that helps.
Well, thank you. We've got we have no more time to answer the questions right now, but I got a couple questions that we can key up for Stump the Chumps later. One of them, you mentioned that you were granted X sheet metal access just today, I think. Have you
Yep,
had a chance
this
to
morning.
check that out?
I have, and I started building a part. In fact, that first design model I had showed up where I brought our Omax water jet in. That one item that was on the screen was the beginnings of a X sheet metal part. A couple, we'd call them edge flanges with a base flange. X sheet metal has some different terms, but they work the same. So again, you
Wow,
know,
so you've had access for less than a day and you're already up and running.
Oh, for sure. And I've
That's
also
awesome.
brought in a part that was, you know, just a dumb solid and already added the bends to it, just like I would do in SolidWorks. So
Fantastic.
if you know SolidWorks, you know X Design and X Sheet Metal.
Well, Eric, I want to say thank you for your fantastic presentation on SolidWorks Connect.
Oh, thank you, Cam, and thank everybody for tuning in. I'm sure excited that y'all were able to make it.
Awesome. All right. Well, Eric, stick around and we'll get back to you during the Stump the Chump session. Okay?
All right, on. Right on.
Cool. I'm going to take over here. And here we go. All right. So at this point, I'm going to start a 10-minute break. Anybody needs to go to the bathroom, get something to eat or drink, say goodnight to the kids, now's a good time for it. So in just under 10 minutes, meet me back here and we will get started on our next presenter. Thank you. See you in a few. All right, everybody. Excuse me. All right, let's go ahead and ease back into things with a couple more poll questions. All right, let's see. How about this one? Let's go with some simple yes and no. There it is. All right. Are you a SLUGME first timer? Let's see. All right. Oh, it's 50-50. It's neck and neck. Yes, no. Uh-oh. One of them's pulling out for a lead. We've only got 20% voted yet. 30%. 40%. Oh, it's a tie again. Let's see. I'll give it about 20 more seconds and then we'll see which one won. I can tell you this is different than the stat we've gotten for this in any previous year. I'm going to go ahead and close this and share the results with you. I'm pretty sure this is the first time we've ever had more first-time attendees than not, except for the first year, which makes sense. All right, let's go ahead and do one more. How many students do we have? Yeah, I'm eager to see what how this poll comes out too, because this is a metric we've been tracking since the beginning as well. By the way, thank you all for participating in these polls. I know sometimes it's easy to just skip right by the polls, but this is important to SLUGME. It's something we've been doing since the very beginning, and it's I don't know if you saw that stats slide. It's something that we enjoy tracking every year. All right. So we've got, well, we're up over 70% voted already. Looks like people are coming back from their break. And we're just about to reach 1 minute on the poll. I'll go ahead and close this. And just share the results. And overwhelmingly, most of us are not students. However, we got a fair few. That even though that's 7% who answered yes at the number of attendees we've got, that's pretty good. All right, let's see. I got time to blast through a couple more of these. This is how we fill that thing out. So how many of you guys are going to be attending 3D Experience World for free this coming February? So again, this is one of those stats that typically leans more one way than the other. Not everybody can make it to World. This year, everybody can. You should be able to, because it's all virtual, it's free, and you can access it from any device. So we will give it, let's see, we're at 40% voted now. We're about halfway through. I'll give it another 25 seconds and see how this goes. All right. Another 10 seconds. Okay, we're going to close this, share the results. And as you can see, for the first time ever, we have the majority of everyone saying they're going to go to World. Nice. And let's see, I got one poll left in here. All right, you guys should be able to answer this one fairly quick. Yes or no? Are you a user or do you work for SolidWorks, Dassault Systems, or a reseller? So when we do live in-person user group meetings, we always strive to get as many SolidWorks employees and VAR employees to attend as possible. And it's really nice to know that even when, you know, on a night like tonight when they're not getting the FaceTime that they might be getting otherwise, it's really nice to know that they're still attending. And we'll see just how many there are. Hey, because you know what's true? They're users too. They like this software just as much as we do. All right, go for another 5 seconds. All right, I'm going to close this now. Share the results. And look at that, 13% of us are SolidWorks, Dassault Systems, or reseller employees. I guess I really should have included also partners who aren't resellers, like DriveWorks and things like that. But that's awesome. All right. So thanks everybody for doing those poll questions. That's awesome. That's how we track this every year. It's nice to see how things change from year to year. And I know this is going to be a year that we definitely want to see in the rearview mirror, right? So I'm going to go ahead and introduce our next guest presenter, Ed Eaton. So Ed has been a SolidWorks user for 23 years. During his time with Demani Group, Ed has consulted for over 100 companies, tackling a wide range of issues. Okay, Ed's the presenter. Okay, I was wondering why I lost that. All right, tackling a wide range of issues with customer models on his way toward delivering a final product design. Within the SolidWorks community, Ed is widely considered one of the most compelling speakers and has consistently had or been a very popular presenter for 15 years at SolidWorks World and at many user group meetings across the US. Ladies and gentlemen, Mr. Ed Eaton.
Hey, everybody.
Hey, Ed.
Hey, Cam.
Take it
Thanks
away.
for setting this up. This is great. So I'm in control now. All right.
Yes, you are.
Well, said hi, everybody, especially any members of the Chicago SolidWorks user group that might be out there. I want to say that I sure wish that we were at Oakton Community College right now instead of me being alone in the conference room at work for hours today. And I'm sure that's the same for everybody else out there, that you all really wish that you could be with your own user groups. So I really appreciate you showing up. And now I'm going to turn off the camera, and there's the presentation, our opening slide. With a group like this, we have people that work in a broad spectrum of industries. And that's true also for my company, the Demani Group. We are a product development consultancy located in the Chicago area, Chicago, Illinois, and we work in for customers in a broad spectrum of industries. And the one thing that's great about this subject of rebuild errors in the context of a user group meeting is that rebuild errors are the one thing that unites us all. Regardless of how you use SolidWorks, whether you're a mechanical engineer, industrial designer, whether you're PDM manager, whatever you do, rebuild errors are in your life. So we're going to do a deep dive into that. Oh, I did want to mention one thing. If you were at SolidWorks World and saw this presentation, or if you were at CSUG and saw this presentation, or even if you were one of the 21 people who have viewed the presentation that SolidWorks posted on YouTube, fortunately, what you're going to see today is completely reworked, and it's probably about 80 or 90% new stuff. So, okay, let's go ahead and break some things. One thing I do have to say that I'm very envious of Eric about is that he was able to use models that he had from work. I don't get to do that, and it stinks from a presentation standpoint because I have great problems that show up almost daily via my job, and due to non-disclosure agreements and the fact that frankly my customers own the data, I can't show it. This right here actually happened to me a couple weeks ago, and I was able to modify the part enough that the fundamental issue is still in play, that it was a very real model, but also that nobody in the world could tell what this thing is. So I'm not violating any sort of non-disclosure agreements. So what this is it's a housing that's around a mechanism that has barely enough room to fit inside the housing. It's so tight that I needed to use a conical spring on it, and I needed to cut into the housing in order to fit that conical spring. And of course, this happened to me at World 2, where I had been dinking around with my file right before the presentation and I wasn't in the correct state. One of the things that is interesting about presenting rebuild errors is that I have to have them be there legitimately and not forced or faked, and then I have to reproduce it exactly. And if I accidentally have it fixed already, then the problem doesn't show up and we have a lull like we just had. All right, so here's a cut I put in for the conical spring. I had the fat end of the conical spring facing down on the screen, and then I had to do a revolve cut to make room for it in the housing. In my 2D sketch, I really hadn't accounted for the width of the or the 3D aspect of the spring, and it wasn't until I went into 3D I realized, oops, oh darn, I'm cutting through the side. So fortunately with the conical spring, all I have to do is flip it, and then we can see if I'm going to have enough room for it to fit. So before making a change to a model, when it's practical, I always try to make a backup copy. And the reason is I already have a perfect example of how to make the model. The feature tree is clean, every step works. And if I make a change to the model and I break something down further in the tree, I can refer to the clean model for some insight on how to repair it. Like let's say I do something and it causes face IDs to change and now drafts don't know what to be applied to, or a shell is missing faces now. The previous copy knows where those were, and that's why I want to have that handy. So before making the change, I'm going to go to Save as Copy and Continue. Oh no, Save as Copy and Open. That's even better, because then I'll have the copy open on the screen at the same time. As everybody should know, it's really important that you do not have two copies, two files with the same name on your network. And I want to be sure to give this save copy a unique identifier. We could do Rev A, Rev B, or any of a number of different things, but that's a lot to keep track of. One number I know is never going to be repeated ever again is today's date. So that becomes a unique part number for the copy. Also, if I really wanted to go through it, I could put down the time, because it will never ever be today at this time again. Hit save, and it's slowly saving to my active folder. Sorry that it's going so slow. And now I'm in the copy. The problem is the copy looks exactly the same as the original, and I never want to get confused and be working on the wrong one. So it is my custom to always change the color of the backup of this copy that I'm not supposed to work on, so that I don't accidentally work on it. And I have picked the Pepto-Bismol color from the palette because that's a color that I just don't care for, and I would never use as a regular part color. So now when I'm going between screens, I can tell immediately this is the work piece, the gray one that I just clicked on. Okay, next up, before making a change to a model, I will usually roll back to right before the feature so that in case something does go south, I don't have to waste time for watching it or waiting for everything else to rebuild. I'm going to know right away whether this thing's broken or not. In addition to that, I will usually do a parent-child inquiry. And if I look at this, I've only got one child. So there's only one thing that I can hurt, which is great. So I'm pretty bomb-proof on the changes. Now you might see that as I'm mousing over features, I'm getting these arrows popping up. Those arrows also are showing parent-child relationships. And does it even for things that are below the rollback bar. So it's a great way to get a visual on how your feature tree is interconnected without having to go and do parent-child on each individual item. To turn those on or off, you right mouse button, click the name of the part or the assembly, and then toggle the dynamic reference visualization. I'm going to leave them on for right now. There are times when I'm not editing a model that I want them turned off because frankly, they make it a little difficult to rename a feature. I usually have to resort to using F2 to rename because the slow double click doesn't work as well because it pops up these arrows. Okay, so now it's time to break this model, which was not my original intent, by the way. This is actually what I did at work. I just wanted to change the dimension from the large OD to the small OD for the conical spring, and then reverse the angle that I measured on the compressed version of the conical spring. So I physically compressed it, a sample of it, and got 15 degrees from vertical for the angle of the side. So to reverse that dimension, I just hit the reverse sense button and closed out of it, and I got this error. Notice that I didn't have an error dialog box pop up. That's because I've disabled those globally. I don't see the point in having a box pop up on my screen that I have to then spend time to dismiss when everything I need is right here in the feature tree. If I hover over the feature, it's going to tell me what the problem is. If I right mouse button the feature, it's going to tell me what the problem is. And if I go to what's wrong, I'm going to get that box pop up on the screen, which tells me the exact same thing that the other two things told me. So, but now I have to hit close in order to make that go away. To my mind, it's a waste of time. Okay, so this cut is just simply not necessary, which is kind of nice to know. I have all the clearance I need for that conical spring when it's been flipped over. So I'm gonna hang on to this feature because maybe I make another change later on and I don't want to lose it. And certainly there's value in the sketch that I created. There's the dimensions and whatnot in the sketch. This is all stuff I don't want to have to research later on. And maybe I want to use this 1.27 offset for the center line to be used for mating the conical spring further down the line. Or maybe I need to add some alignment features. At the time, I didn't know. Actually, now I know. And frankly, that sketch came in handy later on for some other supports in a part that you can't see right now. All right, so this being trees of blood, let's see what the carnage is from a feature that has no children and doesn't affect the model at all. It's crazy, isn't it? We've got a lot of problems in the feature tree and it doesn't make any sense. When you get rebuild errors, your first inclination should not be to freak out, especially if you have a safe copy, because you know how to make this model in a complete way with no errors. Second is you should not immediately go back and put it in its previous state because you made a design change for a reason. Everything we do is in service of the manufactured article. That's, a part is king, and you shouldn't be serving the SolidWorks model and compromising the design. So I'm not going to go back and replace that hole in the side. What I am going to do is I'm going to force a rebuild on this feature tree just to see if any of these errors shouldn't be there. And we've been, people who've been around for as long as I have, I started in 98, we know that to force a rebuild, you hit Control Q. I do like to point out that in the last few years, they finally added a force rebuild icon that you can add in your toolbar. And what it does is the equivalent of dragging the rollback bar all the way to the top and then marching it down one feature at a time, all the way to the bottom. And nothing changed. But at least we know now that the rebuild errors aren't just because the model hadn't thoroughly rebuilt. When you make a model change, the model only rebuilds automatically what it thinks it needs to rebuild, and it doesn't do the whole thing automatically. Okay, time to start fixing the rebuild errors. When you are fixing rebuild errors, you go from the top down. If you started trying to repair this stuff at the bottom and moved your way up, you could find that by fixing one of the things at the top, the ones at the bottom go back into an error condition because of some other change. So we want to edit this feature at the top and see what's going on. All right, this is a split body. I have a surface that is being used to split, but none of the bodies are shown. And this part, even though I had to hide some, has a couple bodies in it, and I'm not sure which one I should be referencing. So that's where the safe backup comes into play. I can go here and look at that same split feature, and I should have paid attention to what the name of this split feature was. I'm pretty sure it's this one. Yeah. And see which body this is relating to. And I can see right on the screen what it is, or I could see it in the name, the cause of the problem. You see how the body renamed to the last feature that contributed to it, which is Spring Draft 7? Once Spring Draft 7 doesn't exist, the body doesn't know what to be called, and that's why the split body failed. And this actually happens a lot, unfortunately, with multi-bodies, and it's been happening a lot more recently than in previous versions. And for everybody that's out there, this is SolidWorks 2019. So I'm going to go ahead, use the information I got from the safe backup to cut the model, attempt to assign. It's going to remember what the previous selection was. And now I'm going to continue rolling down, see what happens. Actually, I'm just going to go ahead and cut to the end and roll to the end of the tree. Model, a tree that had been just completely soaked in blood, is now fixed with one model change. And that is not unusual. And that's why I say, if you run into a rebuild error, don't freak out. You got to work through it anyway. And a lot of times it's pretty easy, especially if you've got that backup copy. So why do we get rebuild errors? Well, because we have chosen to use a parametric design tool. Parametrics, especially for the kids that might, students that might not know, it has to do with relationships within a model, so that when you make a change to the table on the left side of your screen to lower the height of the tabletop and extend its width and length, you can add into the legs could stay in the same place, and then you'd have to edit those individually to match. Or you can create a parametric model, which we do in SolidWorks, where everything updates automatically and logically. As a professional designer, I know that design is about change. You're constantly trying to improve your design. You're constantly experimenting with variations, and you want to be able to set up a model like so, where I can, instead of having to do multiple steps for each change, I can just go right into the model and say, hey, you know what? I want to see what this looks like if it's wider, and let's make it a little bit taller too. So I'm just going to double click that dimension, 22, and usually if I just hit check, the model won't rebuild. I have to hit rebuild, and everything updates. And the reason for that is I've buried some intelligence in this. The seed table leg, the first table leg that the rest are patterned from, is located by mates, and it's located by two mates in particular, where a sketch point is related to, or has a coincident relationship to an edge, and then a second sketch point has a relationship to another edge. And because of that relationship, I'm able to make these updates. And I'm just going to go ahead and show sketches so we have that up for the next step. And for what I did, I had a hotkey that does this, view sketches. One thing to be aware of is I'm going to be talking a bit about how powerful it is to make relationship to sketches. If you want stable models, make relationships to sketches. I'm going to prove that to you. But if you hit hide all types, which is this, you don't get to choose whether you get to see them or not. So it's important to know that if you can't view something, even though you're trying to, this hide all types is the villain that's keeping you from doing what you want to do. Okay, this model is great. It's nice and stable as long as you don't make any changes. And again, design is about, or changes that weren't anticipated at the time that the original model was built. What happens if I want to do something simple like add a chamfer to the underside of the tabletop, which is really common. If you've ever had to move a glass tabletop, you know that the glass is really thick, but it looks thin because they chamfer the edge or put a bevel on the edge to give it less visual mass. When I add that chamfer, now I've introduced a problem because those edges no longer are in the model. And if I try to update the tabletop dimension, the legs are not going to move with me because I made a relationship to something that could be changed by a subsequent feature. This is such an important principle. Whenever you are modeling something, try to make your relationships as high up in the tree and as with as few ancestors as possible. Because it chose an edge, I've got these dangling relationships. If I wanted to, I could reattach those to this edge of the chamfer, and now the mate would be dependent on not only the original boss extrude, but then also the chamfer. By using the sketch, which I'm going to show here, that made the original boss extrude, if I made the relationship to that, which I'm going to do by editing the mate, and I don't even have to highlight the missing edge, it's already highlighted. I just have to, oh, I'm using the wrong one. Just flipped it out. This is the right one. I do that, and then I make a similar replacement, replacing the edge with the sketch line that regionally made that edge. I've taken one step out of the ancestry, and I've got a model that is going to be much closer to being bomb-proof. This graphic is really wordy, and I'm sorry about that, but I have no idea of a cleaner way to do it. but it puts in the hierarchy of all the options I had for mating this leg relative to the outer perimeter of the tabletop so that it would update correctly. Mating the leg to the sketch of the tabletop has the fewest number of ancestors, and frankly, it's practically indestructible because the sketch is defined by itself, and the plane it's on was deliberately chosen to be a base plane so that there isn't an extra step there. But technically, it's got two parents, one who is a deity, basically. It can't go anywhere. Okay, the side face of the tabletop, which is B, would have been a great option because you can't do anything to the edges, like adding chamfers or fillet or running a router bit around it, like with an OG cut or whatever. You could have made that endpoint coincident to the face, and that would have been a really decent option, and only 3 contributors to its existence. The edge has 4 because it relies on any edge relies on the 2 faces that abut to it to define its existence. And one of those could have its face ID changed by a split line or by some subsequent feature and go missing. And then so on down the line to the absolute worst case scenario, which was if you had made a relationship to this vertex, it's not only the plane, the sketch, the extrusion, and the chamfer, but there are 4 adjacent faces. All of that contribute to its existence. Those are 8 things that could go wrong. And please pay attention. This is as simple a model as you could possibly have, and I've still got 8 things that could go wrong in a relationship. That's why thinking about the number of ancestors a thing has is so important if you want to avoid rebuild errors. There are a couple other pitfalls that are kind of fun to talk about in the context of this. And I actually didn't mean to say in context, but that's that wasn't an intentional pun, but it is what we're going to do. So let's say I want to add a hole to this tabletop. I'm faced with a decision. What plane do I put it on? Do I put it on the top plane, which is what the tabletop is on, or do I pick, let's say, the underside of the tabletop, which is exactly the same as the top plane, and then draw my circle there? Well, that depends. It depends on what sort of changes you might expect to happen going forward. If you think that eventually this is tabletop might not be coincident with the top plane, your better play is to make the relationship to the tabletop, because that is not fake, it is actually what you're trying to do. However, it violates what I suggested in the previous slide. I am going to make it, I don't think it really matters. I'm going to go ahead and make it to the tabletop, though I do run the risk of subsequent features causing this to go dangling. And what I'm about to do, I don't think it makes any difference. I'm about to draw a circle, and I'm going to lock it coincident to the origin, draw it out, and add a dimension to it. Yeah, let's say 2. And then I'm going to put in that cut extrude. Because I put it on the tabletop, if I go to through all, which I know it wants to be, or through all both, which is actually what's going to happen, or what I really want, I want to inoculate myself against any future changes that hole is going through this model no matter what. By default, because I picked the face, it's going the right direction. If I pick the top plane, the through all would be going this direction by default. And notice that I don't get a preview. And if I try to accept it, it's going to pop up an error that it can't locate the end of the feature. each direction of the through all is not interchangeable. You would think that through all means through all in all cases. It does not. The first through all has to go meet some material, or else the feature will fail. And I just bring that up as to explain some really funky rebuild errors I've gotten over the years, where the through all thing doesn't go through all, and it's just because the start direction wasn't the one that I wanted. Okay, so I did that. Notice there's no in context relationship, and you'll see the symbol for in context relationship in a minute, because we're going to redo this. And I'm just going to roll it back in the interest of time. Normally I would delete that. I want to, or frankly, I'd delete the sketch and do that, because I want to show you what happens if you do the exact same thing. We'll do it from the underside on the exact same face, draw the exact same circle, coincident to the origin, and we'll pretend I put in the dimension, and then close out of it. I have an in context relationship. You saw that. I did the same thing. The only difference was, because I was in this view, the assembly's origin was in the same visual plane as the origin, as projected into each other. They're actually at different levels, I think. Definitely at different levels, but they're in a line with each other from this particular view. SolidWorks defaults into saying to itself, oh, wow, this person really wants to make this an in-context relationship to the assembly origin, even though they're modeling in the part. This can sneak up on you, so I just wanted to make you aware of it. If you never want to have an assembly relationship sneak up on you, go and activate no external references. No external references to anything in the assembly will not be created. But what's really fun is you can grab stuff from the assembly. You just can't make a permanent relationship. So like here, I started a 3D sketch. Let's say for reference, when I'm back in the part model, I want to have, I should hit do not show again. I want to know where these legs are. I can go ahead and quickly capture that, but no relationships are being made, which you can tell when I go to display delete relations, there's none, which also gives you the ability, which is kind of cool and useful, to have something that could time travel. If a sketch, or especially 3D sketch, has no relationships, has no parents, you can drag it to the top of the tree. And now I've got something at the top of the tree that I can use as a design reference. And I do this all the time. And not even using this, I will also do it this way, where I have something that is defined. And let's go ahead and make it fully defined so there aren't any questions about it. So that's completely black, right? If I go to display delete relations and remove external relations, which I'm also want to do with the in context, I could do that too. There's this drop down where you can choose like external or defined in context or any of these, and you can delete them all at once. I'm going to delete that. Now I've got a sketch that has no parent other than the plane that it's on. And if that were a 3D sketch and I deleted all the external relations, it would have 0 parents and I could drag it wherever I wanted in the tree. Okay. I am going a lot slower than I hoped to. We'll see if Cam decides to let me keep going, or if I'm going to get played off like somebody presenting at the Oscars. Okay, there are 2 types of rebuild errors in SolidWorks when you really think about it. There are the red ones that tell you that a feature could not be made. And then there's the yellow ones that tell you a different story. The feature can be made, but it's not going to be made the way you wanted it to be made. And that is important to know. So a a model like this one right here can have a yellow warning and otherwise be perfectly fine. It's a complete model. And by the way, this is just a fun one that this was on the SolidWorks website when I first started. So if you go to feature properties, and this is you could do with any feature, you can find out when it was modeled and by who. So this is from February 22 years ago, or I guess 22 and a half years ago. And I've kept it because I love this sketch in that it's not something that I would have done, and it's handy to have as an example. So I've got a sketch that's over-defined. Where do you even start? If I go to display delete relations, you can see just how many of the relationships are problematic. If I look at all of them, I don't know, it's almost all of them. It's about 2/3. And it's hard to decide where you're going to start if you were just to look at that field. SolidWorks does have a really handy tool for helping to resolve that, which is this right here, which is odd because you're not expecting a sketch tool to be down at the bottom to the right, but it is a valuable sketch tool in that it's going to start a program that is going to run through all of the possibilities that it can figure out to make this sketch viable again. So it's called Sketch Expert. I hit diagnose, and then I click off this box right away. That box was going to prevent the diagnostic from starting until you read a message, and it takes about as long to read the message as it takes in general to run the diagnostic. So just turn it off is what I do. Okay, it's found 24 different ways that this sketch can be corrected. And what's really cool is it's showing you a ghost image of where it was before it started running through the iterations. And the program just went through and has selectively suppressed or deleted relationships. And you can cycle through them one at a time, but pay attention. What it's doing is it's eliminating a lot of internal relationships. Here is a relationship that is external to the model. Is that right? No, not that one. I just lost it. Going to go through. I'm looking for that one. Do you see how the relationship is something that's floating out in space? That's the one. That's the problem. Because anytime you have a rebuild error in a sketch, it's because something changed on the outside. It's so important to know. If I wanted this to be the resolution, I would hit accept. It would delete that relationship, and now I would have a sketch that I could exercise and then try to figure out how I would want it to tie down or otherwise defined. But that's not actually the best tool for this, because you need, in order to find out the problem, first of all, you need to have something that's seriously messed up, and it still can't find lots of problems because after all, it's just a robot. Your best tool is display delete relations, which looks like this in the toolbar, or if you're a command manager person, got to ask yourself why it has the prominent big center spot. It's because it was probably your single most important sketch tool, because it helps you understand the relationships. I know for a fact that for this to have gone into an error condition, it's something to the based on a model change. It had to be something to the outside, and sure enough, it's showing me that exact same one that I had to go through potentially 24 other options of under Sketch Expert to find. In addition to that, if I have entities expanded, which I just found out last night, I think that's collapsed by default. I expanded it 20 years ago and have never looked back, because it's telling me some really important stuff, specifically what is this thing related to, and it's related to point 1 at the sketch name second point of, and I can't read the rest of the name, and I don't need to because it's enough. I've got enough to go on to see that it was this one right here. And I could delete that and then go and do further querying of the model to understand, okay, this point cannot physically get close to that sketch point. It's not possible because of the other constraints. And it gives me a lot of guidance on how to repair the model. With the type of work I do where I'm getting potentially complicated sketches from other people, I need to be prepared to do this sort of diagnostic work. It's very much like almost like being a Sherlock Holmes trying to solve a crime scene. You're going in and you're trying to figure out what happened, which is also kind of part of the fun of working with models that have rebuild errors. I actually really enjoy it, and I'm not pandering. I really do enjoy it. Okay, let's talk about design change. This is a part that I can show. It is the lid of something that's similar to an igloo cooler, but it has a security on it. So it had a lock, it had GPS tracking. It's because of what was being transported inside. Even though this thing had a very utilitarian functional purpose, it doesn't mean that we don't pay attention to how it looks. And frankly, the thing was looking a little boxy, and it didn't feel right. I felt like it needed to taper off to the sides. But the problem was we already had most of the model done. So what do? We have a design change that we know will make the product better, or believe that the product will make the product better. So we've got a decision to make. Before you make the decision, take a look at the original model that you're starting off with. And this is something I do with models I get from my customers and models for my coworkers, but usually stuff for my coworkers is more consistent because we've been working together and we have a fairly specific way of using SolidWorks that's very stable. Okay, what you want to do is you want to figure out what your changes are going to be, then roll through the model, figure out how it's made. And before diving, if you decide that it's not only salvageable, but that it's going to be more economical to make the change to the original model, which it almost always is, you want to then make that safe backup, get the backup opened as a reference, and then get to work. And it doesn't matter what you break. You can focus on design because you know how to make it. You're using that backup to inform you how to make the darn thing. Okay, there are times, regrettably, and by regrettably I mean we try to avoid this as much as possible, where it does make sense to remodel something from the ground up. A fact of life in design is that when you start up a model or a project or a product even, you don't know where you're going to end up. And there's going to be dead ends, and there's going to be decisions, times when you're going to change your mind. And that is often reflected in a feature tree that's not as tidy or as organized or as linear as it could be in perfect world. We don't go back and remodel everything because it's not economical. But if you're going to be working with a model for a while, it sure helps if it's organized. And it definitely helps if it's not a chainsaw model where somebody models in something, doesn't like it, and instead of suppressing it or deleting it or editing it, they cut it away and then make something else. I've seen lots of models like that where there's just these hack and slash models, or you also see models where there's lots of convoluted steps. It's real easy to make a plane, and I've seen so many people that will start with a plane, make an axis, rotate something else off the axis, and it'll be 5 things, 5 parents contributing to the definition of a plane, when all you really needed to do is draw a line and then fold a plane off of one of the base plane, fold the new plane off of the base plane based on that one line. When it's really complicated like that, it makes sense to remodel, or sometimes when it's a super simple thing. I had this one revolve that a customer had given me. It was a small capstan that I really wish I could have shown as a sample, but it wouldn't be fair to the great person that I was working with. It had the same thing where it was evolved over time, and I tried editing it, and there was many changes that had was in the DNA of that model. Just made sense to remake it as a 3-feature model instead of the 30 features that it ended up being. And those are rough numbers. I don't actually remember what they are. Okay. There is another case that I do want to make, and then that is, when do you never remodel? You do not roll back in a tree and make changes to a tooled component because the tool already exists. If you are going to be updating the tool and not starting from the ground up, you need to work at the bottom of the tree, or better yet, work on a new part that has the old part as a inserted part, so you basically have a derived part. And you saw that sensibility in Eric's presentation. It's not a tooled component he has, but he has a casting. That's an existing thing. You're not going to work on the feature tree of any of the features in the casting when all you want to do is focus on the machining. So you bring the casting into the feature tree as a completed thing, and then add your machining as additional features. Okay, this model right here, we're going to make the actual change. You'll see a number of things in the feature tree. You'll see that there are some in-context references. They don't affect us right now. The reason for them is most likely that the lid needed to update automatically to any changes to the base or the bin below it, the igloo cooler below it. So all of these in-context relationships, they're justified, and I'm not going to go messing around with them. Also, while going through the model, I can see some promising things. For instance, I see features that are named. I'm not going to say that all good modelers name their features, but I can tell you definitively that no bad modelers name their features. If I get a model from a customer and I see named features, I automatically feel a lot better about the situation, because I know that is going to be something, this is made by somebody that is paying attention while they're designing, probably keeping things organized, and they're naming things that they're going to want to go back to and edit, instead of then adding additional cuts and whatnot because they're afraid of editing up the top of the tree. Okay, preview the change that we want to make. I already have a sketch in the model for the new arc that I want, and I already preemptively, for purposes of the presentation, put in a cut from that arc to show you about what we were looking for. Now, this is giving us the taper that we want, but it is not giving us the tangent rounded fillet effect all the way around. We actually have an edge here. Then if we go to deviation analysis and calculate, that's a 46-degree angle on something that should be tangent. There is a temptation to not muck around with the top of the tree and where this thing probably belongs, and instead start cutting things away and doing a lot of surface work in order to add that round. I've seen this a ton in my career. You guys probably seen this too. Especially is true for people that started off with different CAD packages, like a Rhino guy. They're not even going to think about rolling back. Rhino people, they cut away and then remake from the ground up. So you could do that, but the downside is then you're losing a lot of the power of the rest of this tree, especially for something like this where the final dimensions are in flux. This is a palletized product. We had to fit 4 on a standard pallet, and we didn't quite yet know where the hardware was going to be or how much it would project or how we were going to protect the hardware. and what the final size was. So I want to be sure that I have all the flexibility and power of the parametric model that I can adjust and not have to worry about going back in at the bottom of the tree and then having to repair this complicated corner over and over again. Okay, so I'm going to roll through the model real quick just to see about how it's made. Okay, I've got boss extrude. I've got a second boss extrude with a draft going the opposite direction, which is good. Now I know that I probably that the designer probably has established a parting line, which is important. I've got the model getting cut in half by the right plane, which I love to see, because that means that I'm going to see some symmetry coming up. They're throwing away half of the model, and then there's probably going to be a mirror coming up. Then I've got the corner fillet, and then I've got the fillet that I'm going to be having to replace. So that cut has to happen before this fillet, and so I know where to go in the feature tree. I'm going to rename it, and I'm just adjusting the name by throwing in a bunch of center line or a bunch of underscores. Another way that I do that, you've seen this a couple times throughout the presentation, I use these specialty characters I got from Character Map, and that I keep handy on in this Word document that I can get to. And they're great. You just copy and paste them, and you can use them to annotate only the important things in a model, but it makes it easy to jump in. Okay. I've renamed this, which is going to be, it's the fillet that's the most important. And then in a real world, I'd probably go through a little bit slower than this, but I see basically how the model is evolving. I don't see anything hairy. I don't see anything appearing and disappearing. And that's really important to me, because when you're working on a model that somebody adds things and then as they change their mind, they delete it, it becomes a precarious thing to edit. Okay, now I need to get that sketch all the way up if I can. So the visualization is showing me that the fillet that I need to replace and that this sketch needs to be above is a parent of this sketch. No problem. I'm going to roll this sketch up as high in the tree as I can, which unfortunately is not at all. That's because it is absorbed. I could delete this feature, but what's fun is that for the presentation purposes, because that's not always going to be the thing that you're going to run into. If you want something that will always work, you want to change the tree display to flat tree view. This has unnested all of the features that contribute to the model and puts them into the order that they are created in actual history with no nesting. And because it's not nested anymore, I can drag it up as high as is possible. So I want to drag it up to hopefully just under its parent. And then I definitely want to roll back to under this, because any changes I make here, I don't want to wait for additional things to rebuild. I want to get to the next step right away. So I've got the sketch in the right, almost the right place in the feature tree. Now I go to our friendly display delete relations, and remember, parent child is only the external relations in a sketch, so I'm going to query those. I have a coincident to the origin, and I can see that it's the origin because of the entities here. And then I have a collinear, and it's highlighting what it's collinear to. It's collinear to the edge of the fillet. I'm going to delete that. Now the fillet is no longer the parent of this sketch. And I can drag it up. So I got to drag it up to here. But when I first did it, I didn't know that. It's more for, because I'm doing a presentation, I know what to do here. Okay, I wanted to, if I didn't lock this down, this thing would never move. That is something, it is not necessary to lock things down, but I want to lock it down because I don't know that the thickness of this lid is going to change. So let's be prepared in case it does. So I'm going to select the line, and then instead of making it collinear to an edge, which we talked about earlier, is reliant on too many things, I'm going to make it collinear to the thing that I actually care about, which is the top face. And fun fact about this presentation, even though I've been using SolidWorks for ages, I didn't know you could make a line collinear to the face. I never thought to give it a try. I don't know if that's something that was introduced or if it's just something I missed. But what's important by choosing that collinear to the face is I am 1 degree away, or I'm actually making a relationship directly to the thing I want to be related to. I'm not making a relationship to like a pierce point on the edge or this edge here. I've got a direct relationship, and it's as bomb-proof as it's going to be. Now I'm going to use that open contour to make the cut. And because it's an open contour, I have to make it through all both. It used to default to that, not anymore. And I made sure the direction of the cut's the way I want it to be. Boom. Now I've got what I need. I don't want, I could then go back to this fillet and edit it. And you can see it'll highlight the edge that was missing, which is now floating in space. I could select the new edge and reuse this fillet, and I wouldn't lose any of its kids because the face IDs would be maintained even though I'm relating it to something different. What is the problem is that that fillet is dipping because it's constant radius, and I don't want that. We want to have a nice straight light line that looks really deliberate. What's something that's kind of funny is I can't change the fillet type to variable radius or to face blend. I could change it to a chamfer, which is a totally different thing, but I can't change the fillet type. So that means this feature's dead. It's a goner. I can't save it. I'm going to do what's called a face blend fillet with a hold line, but first I need to create the hold line. How do I do that in the most stable way possible? I haven't been in training in a long time, but as I recall, the hold line for training was created with the split line. That is a terrible tool in that it's a great tool. It's absolutely necessary, but it's a terrible tool from the context of rebuild errors because it changes face IDs and edge IDs and vertex IDs in a way that's largely unnecessary. There is another way to pull this off that's going to be much friendlier from an ID standpoint. Actually, if you give me 5 minutes, I can get to the end of this. Okay. So I'm going to go and turn off this command manager thing. I'm a toolbar guy. I'm going to take this plane, and I'm going to use this plane to split this body into 2 bodies. I'm going to cut part, pick one to save, and what it's going to do is take the single body model and turn it into 2 bodies, giving me that line that I want to use as a hold line. To show that it's 2 bodies, I'm going to actually hide the lower end of it. Then I can go to fillet tool, select the face blend option. I've got no idea what's highlighting here. That's odd. Select the 2 faces and pick my hold line. Add the hold line, and you see that it's going to change the radius to maintain tangency to where it meets the edge. And now all I have to do is go bodies, merge them, and I'm back in business. And I have changed as little or few of the references as is possible. Next up, we've already determined this fillet's a goner, so I'm going to delete it. It has a child feature. In the old days, you couldn't do this. If you lost the parent, you'd lose the kids. Recently, they added this advanced button. If you hit advanced, you have the option to save all the kids of a feature. I remember that was the #1 request at SolidWorks World for voting for enhancements for years. And it's been implemented, but you have to expand that box in order to find it. Okay, now I'm going to roll down and see what the carnage is. I'm going a little bit at a time. I've got a sketch here that's got a couple of things that are dangling. And that sort of stuff is easy to repair. You can get normal to the sketch and then find out the stuff that's dangling. I could go to display delete relations to find it quickly. And I can use display delete relations to repair it, but it's a lot faster and more fun to highlight it and then just drag it to what it's referencing. It's a lot more fun when I'm actually on the ball here. I'm going to turn off the relationships, going to highlight that, and then I just highlighted the red thing and then I dragged it and dropped it onto this vertex. This did something that you would think is scary. It has over-defined a sketch that wasn't over-defined previously. And the reason is this fillet is just a little bit different than the one previous. So 8 decimal places out or something, this point has moved. This dangling one has not moved. It's essentially fixed in space where it was by what its absent reference. What I need to do is drag the red thing dot to its new reference, and now I have a sketch that's healed itself. Reinforcing the thing that you just don't freak out about a rebuild error. And we got a bonus rebuild error that went away because of the last one we fixed. Next up, I'm going to repair this fillet. Repairing fillets is real easy, especially these days because the missing edge is highlighted for you. It even kind of knows where it was, even though, but because it's got a different ID now, because it's attached, it comes from a different fillet, it doesn't know to reattach itself, and it needs a person to come through and do it. And for rats, it looks like when I was scrolling, the radius value got overwritten with the letter T. So no big deal. I'm gonna repair this, and I'm gonna go forward. There's one more repair that I want to show you because it's a real crowd pleaser. And then we'll be done. Okay. I've got another dangling dimension here. And that is, oh, I'm in the flat tree view. I didn't even notice that. Normally I wouldn't be, but it doesn't affect anything here. Okay. I have another dangling relationship. And this, unfortunately, is an offset relationship. It's only one edge right now, but in most models, you'll offset multiple edges that are in a chain with each other. And if they go dangling, it can be difficult to repair. They're time consuming to repair because you have to do each one, and you can't just highlight it and drag it to its reference. You have to go through display delete relations, but you can fix it. Expand entities, and I've got the offset highlighted. I've got a dangling line and then the fully defined line. Fully defined line is the sketch. The dangling, I highlight that and I tell the offset, hey, I want to replace you or the missing reference with this. And now I have fixed the offset relationship. And one of the reasons I wanted to fix it instead of deleting it and remaking it is because there's this link value on it. And I'd have to recreate that link value. And it also flies in the face of just in general, you don't want to have to delete anything if you don't have to. Okay, a lot of stuff magically fixed itself, and then finally I'm going to head down to the mirror. I'm almost done. Oh crap, the mirror's failing. This one's funny because it's a mirror body. It knows what the body is. It's just that with the control Q, it doesn't fix itself. It will continue to show that it doesn't have the body, even though it totally does. So you have to delete that and then just pick it again. And now the mirror works. And most importantly, the child features of the mirror work. Okay, I think that's about it. Oh, final thing regarding offset, repairing the offset sketch. There's an actual dialog box inside SolidWorks that tells you that entities with offset or converted relationships cannot be replaced. Well, this message is bogus because I just showed you how to do it. I didn't show you how to replace convert because it's exactly the same as dragging that meatball on the dangling corner. They're really fast and easy to replace, and I've been doing those for 15 years. Don't trust any dialog box in SolidWorks. Test it for yourself. It is in fact true that this dialog box is factual relating to Pierce relationships and the intersection of two faces. So you do have to give it some credence, but take it to court and really give it a trial. And then, yeah, that's enough.
Thanks, Ed.
Okay.
There are a few questions I was wondering if you would answer. One of them, can you explain what a face ID is?
Yeah. That's a great question. Everything in SolidWorks has a name. It has to have a name. So let's say, I'm going to roll back here for this fillet. So how does fillet 6 know what it belongs to? How does fillet 6 know that it belongs to these edges and not maybe some edges over here? It's because the edges that fillet 6 is being applied to have a name. And it's not the name you see here, edge 1, 2, 3. Those names are for our benefit. The name internally is probably some wild number or text string, but I like to think of it as, Mo, Larry, Curly. And when you add a split line or something that would change the name, Mo could become Chewbacca and Larry could become Leia. And anything that was looking for Mo isn't going to find Mo anymore. And you have to tell Mo, no, you belong to Chewbacca now. I hope was that clear? At least to you, Cam? Okay.
Absolutely, and it's not just, it's faces, it's edges, it's everything has a designation within the software, and there are certain actions that you take that will rearrange pre-existing names. So when you go back and edit your feature tree, there's some things that can kind of mess with you.
Well, and that's one of the reasons that, like, I cringe anytime I have to pick a vertex, because the identity of that vertex is defined by a minimum of 3 other things. Actually, it's 6 other things. 3 edges and then 3 faces, minimum. So vertexes are scary because there are so many things that could have their face IDs or edge IDs names changed, and now the vertex is something new.
All right, the next question, actually, we got this question quite a few times. People were commenting on the special characters in your feature tree. I know you touched on it a little bit. Was there any more detail you can add to that? And also, we had a request, can you share that document with us in case we want to use it?
I can share that document. I have no problem with that at all. I was all prepared for this. There's a whole bunch of weird stuff in my feature tree. The document are codes that I use so that, like, if I'm doing a sketch layout sketch, I hit it with an LO. So I know later on that that's something for reference. If I have an X, that means I can delete it at any time. I do a lot of copying and pasting of sketches as references, or that 3D sketch trick that I started showing. I do that to capture stuff like even in an assembly, capture positions of a thing, of all the components, then delete the relationship so I can drag that up to the top of the tree, because history's great, but it's also obnoxious when you can't use something at the bottom of the tree when you're building something higher up on the tree. Using the 3D sketch, you just don't want to make any relationships to it, and that's what the X is for. WA is workaround, that's important, and then the other ones are just things that I like. Like I couldn't find a check mark in the character map, but the square root sign looks close enough. So I use that as if I've gone through and I really know that something's locked down, I'll throw the check mark in so I know never have to go back. So how do I share this document?
So we have, you're an organizer. In your control panel, there is a handouts section.
Okay.
Oh,
Handouts. I do want to also comment on.
actually, I'm not sure we can put anything in there. I used to be able to drag and drop into there, but it doesn't look like I can right now.
Okay.
Tell you what we'll do. I'll post it to the SLUGME 5 forum post that I've been sharing with everybody in the chat. Yeah, you can send that to me separately, or you can put it there yourself.
I did also want to point out the comments. In my models, I'll tend to use comments a lot. Those good. You can right mouse button, click a feature, and add a comment, and that will be instructions that will only pop up if somebody's editing that feature or hovers over that feature, queries the comments. It's a great way to convey design intent, but you have to turn them on. And that's why you'll see like comments in my at the top of my feature tree, and for a feature or sketch that has a comment on it, you'll see this little like notebook page. So those are icons that most people are probably not familiar with. Okay, next question.
I think we've got one more. Mostly you're getting a lot of high fives and thumbs ups. Everybody's really loving your presentation.
Thanks, everybody.
So it says, he mentioned that converting a 3D sketch, table legs, without external relation and moving the feature to the top of the tree. When is this useful?
It's useful all the time. I actually, here's one. Before I make a change to a model, like this one right here, I'll look for critical features, like where these mounting bosses are. I'll start a 3D sketch, hit the E key, which turns on the edge filter. I'll grab the edges of things that I'm afraid of changing by accident because I don't know what all the dependencies are. This is a simple model. When I get something from a customer or even a coworker or even myself, frankly, after I haven't been on it for a while, I don't know what's going to change. And I don't want to have to create an assembly with a prior version of the part to find out. I just want to have it right here handy. So I converted all the edges. I then used display delete to remove it all. I'm gonna hit the E key to make the filter go away. And then I'm gonna take this and I can drag it all the way to the top of the tree. And I always try to remember to rename it with that X, so I know that I can delete it at any time. I'm not going to take any more time on that. Okay, let's say I needed to make a change to the feature tree like this one, where I have a feature that I don't want to be in that position in the tree anymore. I'm going to deliberately bring it into an error condition so it can't be built. And that allows me to edit the kids away. So I have a fillet on the edge. Bear with me, your answer is going to be in about 60 seconds or less. That got corrected. Then I've got the screw holes. I'm not going to repair the sketch for the screw holes, but I'm going to replace the plane. that feature that I just sabotaged that's no longer in the model was the face that these holes were on. So I'm going to move those holes to this face. And then I'm not going to bother fixing the shell because it doesn't make a difference. To your question, those fixes are trivial. Now check this out. Because of the way those holes were defined, my mounting bosses suck. They're in the ends are in the wrong spot. If I built this thing, it wouldn't fit to what it's mounting to. It actually hover above. I can see that instantly because of that 3D sketch. I didn't have to take a measurement. I didn't have to write anything down. Automatically. No. I
That's
use this
clever.
constantly. Another
Yeah, I
thing
like
I'll
that.
do to make it jump out is I'll change the sketch color. There's a deep purple and a deep red that I use for these because it's not like any other sketch. It stands out. And again, you know immediately there's something that's changed or that there's something that hasn't changed. This lower edge perimeter didn't change. Hooray, great. And then finally, for people who are wondering why I sabotage features, it's because then it allows me to actually drag it, change the parentage, and I can take a feature from the top of the tree that I had a bunch of kids, and I can drag it all the way down to the bottom. But that's something for another presentation. Once you know about sabotaging features, they become really handy.
Nice.
Yeah, but there's too much to talk about in even an hour.
Yeah, you just definitely, that last bit showed some people some stuff that they hadn't seen before. I'm getting some comments. That was cool. All right, well, that's all. Whoop. Let me read this one last question. All right, Ed, if you would like, you can provide those last few slides to me, or you can post them on the forum if you'd like to go through those. If not, if you've already covered that content, that's all they were asking about. Everybody
They
wants
want to
more.
know what the last slides were? I mean, I'll just give you the whole presentation. But yeah, there's a whole bunch of little miscellaneous stuff here that recaps. There's this sketch that I didn't get to that Sketch Expert doesn't do a good job on. But, you know, anybody who knows me knows that I prepare way too much material. I could probably go 2 hours.
That's the way to go.
Yeah.
All right. Well, unfortunately, I'm going to have to snag away from you here.
Go for it.
Ed, thank you so much for that. That was an awesome presentation. That definitely.
Thanks for the invite. That's a lot of fun.
Yeah. Yeah. I don't know. You mentioned it a while ago, but back in Nashville at World, Eric Beatty and I actually sat in on your presentation, and when we walk out of there, we're just looking at each other, knowing that we were on the SLUGME committee, just looking at each other like, yep, it's got to be Ed. So, yeah, really glad you're here, and I'm pretty sure everybody echoes that sentiment. All right, I'm going to take over.
All right, so long, everybody.
Later, Ed. Am I sharing? I am. Okay. All right. So real quick, I got a couple things to do, and then we're going to get into the remaining questions and stump the chump. So I've got 2 poll questions that I apologize I didn't get to earlier, but they're important. Both of them need to know as quick as you guys can respond. What certifications do you have? This is a select all that apply situation, so get it. So we've kind of grouped together the CSWP advanced exams, and we've grouped together the, nope, that's it. I thought we had included the certification or the simulation exams. I apologize. But if you have one of the simulation exams, you can include that as one of the other levels because there's 1 per level there. All right, we've had that open for a minute. I'm going to go ahead and close that and share the results. And it looks like we've got a fair amount of CSWPs. That's good. I've got some people who have yet to earn a certification. I highly recommend it. Highly recommend it. All right. I could definitely talk about that for a while. And last but not least, this is by far the most important question of the night. What are you eating? Yes, okay, this is going the direction I was hoping it would. Oh, never mind. Some of you people, I just don't understand. What? I'm loving these answers. So while I wait for that to finish, I'm getting a lot of questions about the shirts. So we have the SLUGME shirts on, and these were made from the logo that Ryan Purdy put together, and it is awesome, and we love it. I have another shirt design that I've been working on that I'm going to show you here in a minute, and we'll talk about when you can get one of those. I'm going to go ahead and close this poll here in just a minute. Well, I'm glad I put that option in there. I'm going to share the results. And that's awesome. Almost half of us are eating pizza. Well, I'm really shocked, actually. Some PB&Js came through. That was stayed at 0 for a long time. So hopefully next year we'll get back to tracking how many actual pizzas we have consumed, because that is a ridiculous number. All right. So I'm going to show you guys this. I'll drag it over here. See if you guys can see that. A delay. All right, you can see that. So this is a modified version of the logo that I'm going to put on a T-shirt, and I'm going to make this available. Probably going to make this available the same way that I did Todd's design of the Ekgar shirt for Danielle Boyer. Now, if you don't know who Danielle Boyer is, you should. She's amazing. She is here listening. She's probably soldering. She's also just turned 20 yesterday, so happy birthday to Danielle. I'm going to flash a website up here real quick and show you guys this is the shirt that we did before. All proceeds went to Danielle, and one of her many endeavors to make the world better. Every Kid Gets a Robot is something that she put together to help kids who might not otherwise have the opportunity to get involved in robotics. And this is something that SWGN and very specifically a handful of us have been really pushing for a long time. We're big fans of Danielle. And I think here, so this shirt is still available if you want to get it. If you see up here, it's just bonfire.com/Ekgar. Every Kid Gets a Robot. And you can Google it. This is also, I think, where I'm going to put up this year's SLUGME shirt, and I don't see why we wouldn't support Danielle further with the proceeds for this year's shirt. So, yeah, hope you guys all like that. And let's get to the last section of the night. I know we're running a little bit late. I wanted to say, everybody, thank you for coming. If you have to run, we understand. Thank you so much for coming to SLUGME 5. This is something, it's kind of a passion. And if you know Todd Blacksher, you know that crazy ideas like this don't always work out, and we absolutely love that it continues to, and we're going to do our best to make it go every single year. All right, so let's move on to Stump the Chumps. At this point, I'm going to go ahead and ask for my chumps to turn on their webcams and their microphones. Hey, welcome back, guys.
Hi.
All right.
Hey there.
Sweet. All right, so I know you guys are chomping at the
Is
bit.
this
We've
where
been
we
looking at
start
the questions.
singing "We Are the Chumpions"?
Somebody had to do it.
I know, right?
Yeah.
We're gonna watch the numbers
Yes,
drop
I
quick.
went there. Oh, hey, look at those numbers plummeting.
All right, so I'm gonna go ahead and we got some questions lined up. I'm gonna go ahead and share this.
Bring them on. We
Yeah.
are eager to,
All right.
except for that one.
What are smart components and how do you use them? Anybody wanna?
I'm gonna defer to like Dan or Todd or somebody.
Right.
See, these are what's used to make smart cars. So I'm going to go with lug nuts.
Yes.
I've never heard of it.
Okay. Well,
Sorry.
And that ends our episode.
I refuse to get stumped on the first
Hey,
question.
that was fun, kids.
That's
Well, everybody
gonna
pack up.
Thanks for playing.
Oh,
Hey.
Cam's making a call.
yeah. I'm gonna phone a friend. Hey, we got a question that we need help on. Would you mind joining and helping us out here? Oh, awesome. Thank you. All right. See you in a minute. Okay. I think let's see if that fixes our problem. And
What'd you do, Ray?
hey,
What?
hey, everybody.
Hey,
It's the Mark Schneider.
Gentlemen, how are you?
Good. How are you?
Excellent.
Doing well. I'm doing
So,
well.
the original modeling maniac.
I'm a maniac, all right. You got the maniac part right.
All right, Mark. So we got a question here. What are smart components and how do you use them? Can you keep us from getting stumped tonight? Question number one.
Yeah, I think I can. So smart components are parts, sub-assemblies, whatever that you might have that are commonly used things. You use them over and over again, and they may contain like accessories or mounting hardware or special features that you add to mount, to that get used every time you use them. So let me see if I can scare something up. So I did something a long time ago, Cam, where I put together a demonstration that used a lot of the smart components because I was putting together a demonstration for machine design, and I found that, hey, I'm looking all over the web for these things all the time. And yeah, this is the one. And I'm looking, gearboxes, bearings, motors, things like this. And every one of these things I kept finding had, take a gearbox. I always got to have mounting hardware for that, or a bearing. It's always got to have certain fits to it, or a snap ring. I always got to cut a snap ring groove for that as well. So let me show my screen. And this is something I did. I did this like 15 years ago. So smart components have been around for a long, long time. And I don't know, it sounds like, if Dan says he's never heard of them, maybe I can walk you through some cool things here. So this is just an assembly. It's just a machine assembly here. So what I'm going to do is I'm going to hide this. And I actually have a whole bunch of them. I'm not sure how much time you got to go through these, but I'd be happy to kind of buzz through, show you how to build them, show you how they work. Let me show you how they work first. Let me switch to a different display state. So I have this gearbox that's hanging in my assembly here, right? And it's not mounted. You can see there's no mounting for that, no screws, no hardware. I need to put a motor on the front of this. So in my design library, I can go to this folder here, which has some parts for, just bearings and sprockets and keyways and leveling screws, all different kinds of things. So if I take a motor like this, and this motor has made references on it. I don't know if you want to get into made references and all that kind of stuff, but made references are basically stuff that's built into the part that allows me to automatically snap it into position. So I'm going to take this motor, I'm going to drag it in, and I'm going to snap it right onto there. So that's mate references there. That has nothing to do with smart components or anything. But if we look at this motor, you can see that this motor, I will actually isolate it and show you what that's got. It's got some tapped holes in it, you know, so I'm going to need to have some mounting screws that go through there. So what do? You go to Toolbox, you go to however you're doing your hardware, you start assembling some lock washers, you start assembling your screws, you put those in there, maybe you pattern them or whatever. But since we do this every time I use this motor, what I did when I started going through and building this demonstration was I said, well, why don't I just capture that information with the motor so that every time I use the motor, the right screw always comes with it. So if I take a look at this part, you can see in the tree, see the little lightning bolt that's on there? Got a little lightning bolt? You can see that?
Yeah.
I got a little lightning bolt there. That tells me that that's a smart component. If I click the part in the tree, this little smart lightning bolt feature pops up, and I can hit insert smart fasteners. So what this does, it opens up another little window there, and it says, hey, these are your smart fasteners that come along. Also look in the graphics area, they got smart fasteners in there. So what's coming along with it? Got a bunch of socket head cap screws, some lock washers. So I'm just going to go ahead and do this, and I'll show you how to set these up and how to build them if you want to go that deep. So it assembled the screws, but it did not, you know, assemble them in that direction. So I will add a mate between here and here, and we'll just go ahead and make that coincident. So just like that, I assembled this guy and assembled all 8 screws that go along with it. So that is a smart component. Does that make sense?
Yeah.
So we have the smart component. So what about this gearbox here? So every time we assemble this gearbox, what do I got to do? I got to put screws and bolts in it. I got to build a mounting plate for it. I got to tap the holes in the other part for that mounting, for those screws that I'm putting in there. So let's take a look at this one. One thing you'll notice is this is smart as well, so you can see it. If I just choose the item in the graphics area, it highlights the face. It doesn't give me this little guy here, so I have to choose it from the feature tree. If I don't do it that way, I can always just right click and say insert smart features. Same thing. So we insert smart features. So what's this one going to do? This one's going to bring in an extrude. So that's the base plate. It's also going to bring in the tapped holes. Those are the tapped holes that go along with it. It's also going to bring in socket head cap screws. Those are there that'll mount that. All I need to do is define a face. So for this one, I need to define a face for the external references so it knows, hey, what part do I want to put these features into? So all I'm going to do is choose this face here because that's where I want to mount it. So I can turn this preview features on, and that'll actually build those features for me. The way I built this one is I set this up to be an up to next, so it started on this face of the bottom face of the gearbox, and then it goes up to the face that I selected. So that brings that plate in there. I'll hit OK. You can see what that does. Not only does it bring the 4 screws in, but if we hide this guy, the 4 screws, and we'll hide one of these, you can see it brought in the tapped holes as well. If I open this up in its own window, these are now features in this part. So these features came into the part. You can see that this is the smart feature. It contains the extrude and it contains the tapped holes. This does have an external reference. So if that gearbox ever moved around on the assembly, these would update as well. You can break the external reference if you don't like them as well. But I mean, that's kind of in a nutshell is that commonly used things that you know every time you use these things, you gotta create the same types of references over and over again. Or it's the same, awesome. You know, adds the same extra components, and then maybe, you know, in this case here, we're adding some extra features along with that as well. Want to see some more?
I need to use
that. Show us how to make one.
Yeah, I can show you how to make one. Let me show you. I don't want to, let's close this guy down. Yeah, we can save that, that's fine. And we'll bring everything back here, bring all those guys back. Let's go to a different one here. Turn on this all components. So if we look at this little jack shaft assembly, let's open that guy up in its own window. So I built this one because, you know, I'm putting this bearing in here. I cut a cross section of it so we can see what's going on. So you can see I have a shaft. I have this, you know, little bracket that's holding this jack shaft in place. I have a bearing that goes on there. I have a cut on my shaft and an undercut, you know, to accept that bearing. I also have a pocket that I've cut into this part here, and that has certain information that's comes along with it. You can see that it's got the fits on there. It tells me this is the radius in the corner. It also has a snap ring here and a snap ring groove. Every time I put a snap ring in, I got to put a groove in. Every time I put this bearing in, I got to go look up the fits. And for me, I still look them up in the catalog, but you know, you look them up online, right? So if I wanted to do another one of these, let's put another bearing over here. So let's come to my bearings here. And you know, again, I started off doing this because, you know, hey, I want to show how machine designers might use this. Well, machine designers use a lot of off-the-shelf parts like this, and these off-the-shelf parts have features that kind of go along with them is very key and critical. So let's put this bearing in. And I'm just going to drag and drop. And you can see that as I move that around, this auto-sized. It will auto-size to the right side. So I'm just going to place that in there. And it, because of mate references, gives me a concentric relationship there. We'll move this guy down, and I'm going to put it down. I'll make this and this coincident. Now this top one, remember, had a cut down, and this is a 20 millimeter shaft here. It tells us right here on the status bar. If I look at this bearing here, it's a 20 millimeter bore. If I want to put a 17 millimeter bore in there, I can. But if I cut my section now, you can see that, you know, I got to cut this material away. I got to cut material away in the housing as well, right? So that's you know, that's some work, and I got to go out and look up those fits and whatever. So what happens if I just use my smart fastener or my smart component? This is a smart component here. So let's open this, or I don't want to open it up in its own way. We'll come back to that. What I want to do is I want to insert the smart features for that. Again, this has the little lightning bolt on there, so I can insert those smart features. And in this case here, it's not bringing in any extra components. It's only bringing in features. All right, so it's got the shaft cut, it's got the shaft undercut, which is that small undercut there. There's an undercut fillet that goes in there, a full round fillet that I think I added. Housing bore, so that's the cut for the housing bore, and then the housing bore fillet, which is that little fillet in there. So these are things that you look up in the catalog over and over again. So what it's asking for here is references. Okay, so references, so here's the shaft. It knew because I mated that onto the shaft. It knew that that was there, and you can see the features that come along with that. And then the component for this feature is just this part here, so I'll click that, and I'll say go. I can do the preview features. It's just going to generate a preview. So what happens now? Take a look.
Nice.
Right, so if I look at this feature here, you can see that it's got the fits. So that all that fit information is inside of my smart feature. I put all that in there so that I know that, hey, this is a J6 fit on here. I want that information to come along there. Same thing for, we look at our smart features in here. There's my shaft cut, my undercut. That's just a cut there of a certain size, and then the undercut fillet, which is a full round that goes in there. So you can see how that goes. Snap ring, let's put the snap ring in. So do the same thing here. Where's my snap ring? There it is. We're just going to take my snap ring, drag that guy onto here, and maybe click concentric mate. That's fine. That puts it in. You can see it already cut my cross section. So I'll add a mate, put that like there, and then we'll insert our smart features for this guy. Here it already knows everything. Well, the component for the feature, we want to cut that into this. All right, so that cuts the snap ring groove. Awesome. So what you're doing is you're these commonly used things that you use over and over again, you're just able to embed information in them. So we look at this snap ring here. You can see this is snap ring. It's got a whole bunch of them in here. way I created this is with a design table. So I'm just going to edit in the same window here. So this will pop up here. It's actually a fairly big design table. It's got a lot of stuff in it. And what I did is I went to the manufacturer for this, it's TrueArc, and I copied their web page is basically what I did, and I put it on sheet 2. Bring this guy up, here we go. So if you look at this, this is straight off of their web page. And I leveraged some of these columns and whatever to build what I wanted. But here, sheet 1 has all the information. So here's my, configuration name, description, whatever, and then all the dimensional information that defines that snap ring. So I, just built a regular table and all that information. But one of the things I have here is some information about the groove. So that's the groove information. And where does that groove information come from, or how is that useful? For I have a feature here called groove. And that has all the dimensions that are in the design table. So these are the dimensions that are used to control that groove. And that groove is basically information straight out of their catalog. So I'll create one from scratch if you want me to create one from scratch, but I'll show you what's in here. So what happens when you make a part smart like this, you can say edit and defining assembly. And what you do is you create an assembly. And you make a dummy part like this. What is it called? Retaining ring shaft, whatever. It doesn't matter what the name is because you don't even need it anymore after you're done. So I created a part, and then in this part, I created a snap ring groove. See the little L? Might be tough to see, but there's a little L on there that shows that snap ring groove is a library feature. It's kind of like a library feature that gets stored. And that just basically is a conversion of this groove sketch here. So that cuts my groove. So you, again, just all you do is build an assembly. We'll build one from scratch. And then for the definition of this, you say, do you want to add any extra components, all your screws, nuts, bolts, whatever, blah, blah, blah. What features do you want to add? And you can do that. You can even do the auto sizing. So when I drag and drop that in there, that's what does the auto sizing. The toolbox parts, when you drag a toolbox part in, it'll auto size to the whole size. With the smart component, you can set that up to do auto sizing as well. So I set this one up to be auto size. So here's my configuration name. You can set that up and key in a minimum maximum diameter that you want for each of those. I can show you how to set those up if you want. So that's basically it in a nutshell.
That's awesome.
I mean, the key thing with a smart component is that you are able to create these commonly used parts that have, I call them accessories or certain mounting conditions or mounting information that needs to go with them every time. If you're using these things over and over again, there's no sense in trying to reinvent the wheel over and over again. You could have just gone with just the sketch inside of my snap ring and used it to create the feature, to create that revolved cut each time. But the smart component just allows me to automate that. And you don't have to use them. You don't have to, insert the smart features.
Right.
So let's see if I'm going to add this.
Speaking of that, you so after you've inserted the smart features and you've edited your assembly, like Alin Vargatu asked a question. Can you demo how to dissolve a smart component within your assembly?
Yeah, they don't dissolve real well. Like I can't just say, hey, I want to dissolve that. What I can do for like this feature here, if I wanted to, actually, let's do this. I'll delete this one. If I delete that part, I got to control B this. Usually when I delete these, the part that it was cut into just needs to be rebuilt. So all I did was do control B to rebuild and get this part back. So I deleted that. What I can do is if I wanted to have that snap ring groove go into the part and not have an external reference, what I can do is just drag this guy in here. We'll add that mate there, or a concentric, and then I'll make this and this. We'll make this coincident. That's good. And then I will insert the smart features. There's an option here that allows me to update the feature if the component is moved. So if this component moved, you put a bigger bearing in, you change something. If I uncheck this, I got to choose my reference, which is going to be this guy. If I uncheck that, you can see I have just my feature there, but where'd my group go? My group didn't go. Let's try that again. Insert more feature. Component for feature is going to be this one. Component for feature is going to be this one.
Uh-oh.
Uncheck that. Usually I had to look at that one, but usually if I do that, the feature goes into this part. It just won't. It won't have an external reference to it.
Gotcha.
But it still gives you the feature. I need to look into that one, see what's going on with that. So how do we set this up? If I wanted to put a pulley on here, let's do. I have a little. What do I got? I got this one. So make me smart. Let's open up this assembly. So this doesn't have any, it does have smarts to it. I got that wrong. Something, okay, so let's just delete the smart feature. I'll delete all that. No, we're good. So the only thing I did, this is a pulley. I want to make this pulley smart, okay? And it's, you know, it's got a set screw and that's going to go onto a shaft. Every time I put that onto a shaft, I might want to grind off a little bit of area for where the set screw sits so it doesn't mar the shaft, right? So what I did is I created a plane here. You can see that that plane sits at the end of this sketch here, which is the hole wizard hole. So all that plane is defined by the end of this line and that vertex. So that puts me always at the end of that hole, no matter how this part changes, because this part actually has multiple configurations. It's got a 16 millimeter bore and a 20 millimeter. And that plane moves each time because the way it's defined. And then I just created a sketch on that plane, and I'm going to use that sketch to create a flat on my shaft for this head screw to hit. So I'll add, so we'll go back to, right now this part is not smart. I'll go back to my assembly. I created a simple assembly with just a very simple shaft. There's nothing in it. Shouldn't be anything in it. I guess I didn't delete all that stuff the last time I did this. So there's nothing in there. So let's do this. Let's explode. You can see simple shaft, nothing in it. I got a set screw down there and that looks good. Okay, so let's make this smart. So I want to make this part smart, and every time I put this smart part in, I want this screw to go, and I want a set screw flat on my shaft, right? So first thing we do is, again, this is just an assembly here. I'm going to edit this part, and I want to create a sketch, and I want to create a sketch on this plane. So this is the plane in small pulley. So I'm creating a sketch in this part, starting from a plane that exists in the pulley. So I'm building that reference there. So we'll create a sketch there. With this flat right here, that's the sketch that's in the pulley. I'm going to convert those entities. And then I want to cut some material. I'm going to flip my direction, and 1 millimeter is good. So all I did there is I built, let's hide that. Oops. Hide that one. All I did was build, and this screw is assembled to that plane that I created in the small pulley. So when I assembled that screw, I assembled it to the end to that plane. So I created all I did here is I created a cut as an external reference to from the sketch in the pulley and from the plane in the pulley. All right, so that's all I need to do is to build that. We'll exit out of edit component, and I want to make this part smart. So you're going to make a part smart when you're typically when you're in the context of the assembly, because you're wanting to put extra things in, like extra mounting hardware or, you know, features into another part. So let's make this part smart. I'm going to go up here to tools, large assembly setting. Oh, not large assembly settings. That makes no sense here. Tools, turn that off. I want this part, and I want to go Tools, Make Smart Component. All right. So now I'm in this environment to make this part smart. So the smart component is a small pulley, and the components I want to add are just this screw. The features I want to add, you see it hides the component, the other components there, gets them out of my way. I can add this. If I had added a couple little fillets in there, I can add a couple little fillets to make that manufacturing that easy. I won't get into the auto sizing here, but that auto sizing is what I showed you earlier on the snap ring. I can build that up if you got time, if you want to see that. Okay, so that's it. That's really it. So I've now made that part smart. And that small pulley exists there. So let's take this guy. I'm going to save it. And I'm going to close it down. I don't need the assembly open. I don't need the pulley open. I'm going to put that pulley on this shaft here. So where is it? Small pulley. Take this small pulley, place it on this shaft here, and I'm going to drop it. Allows me to choose the size. If I wanted to have different sizes, I'll choose that one. I want that to be concentric, and we'll place that. I can add a mate here if I wanted. I won't add that mate. What I want do want to do though is let's rotate this around. You can see that the shaft and the pulley aren't aligned. Let's add a parallel mate there so that those move together, right? You want to do something like that. So I want to put those mounting features in here. I want to put the cut into that shaft, and I want to put that set screw in there. So if I right click on this, insert the smart features, there's the cut extrude that I did. And what Ed had said before, name these features. It's always a good idea to name these features so that when it pops up here, it'll say set screw flat or something like that. It's going to put, and I can choose if I didn't want to put the features in and only wanted to put the set screw in, I could do that as well. Just uncheck each of those. So here's your cut component for the feature. It knows that one because it was assembled to that shaft there. So that one's pretty easy. And I'll say go ahead and go. So what did it do? Hide that. You can see it put the wrench flat, put the flat in there for the set screw, and it also put the it also put in the set screw.
Right.
You can see.
Fantastic.
Yeah, I mean they're kind of fun because it'll add those features to your model. And then the cool thing is if I move this down and I hit rebuild and I hide this guy, it has that external reference, so it knows where to move that and where to put that.
That is pretty cool.
So it's one of those things. It's not for every part. It's you don't use it for everything, but those things that, hey, I do over and over again. Watch this one. I think I have another example. Let's see if this one works.
What's cool, Mark, is that you're answering questions as they come in without even knowing they're coming in. Yeah, that's awesome.
Let's put this guy in. So this is a larger pulley, and this is a larger pulley that has a taper bushing on it. So this needs a taper bushing. Every time I use this, I got to put the taper bushing in. Every time I put the taper bushing in, I can put the mounting hardware in. Every time I use this, I got to cut a keyway in my shaft, right? So I just inserted a part here. This is a smart component, so I can say insert the smart features. What's this got? It's got SD bushing, it's got SDS bushing, all the hex bolts and lock washers. Go. And it puts those in. I'm going to just drag this down. It's not mated in place.
Wow.
So, but this, it's not, mated in place. This is embedded inside of, so I have a smart part inside of a smart part. So this is a smart part too. You can see the SD bushing comes there. If I say insert smart features for this one, what this one's going to do is going to cut the keyway in the shaft and put the key, right?
Wow,
Component.
cool.
I want to cut that into the shaft, and I'll say go.
All right. I think we're going to have an entire presentation on just this.
And just on smart
Certainly
components.
sounds like it.
Yeah.
And then if I drag and move this around, hit rebuild, it'll move the keyway.
That's awesome. Yeah, they're not for every
Yeah, they're not for everything, but it's like every time I put that bushing in, I gotta cut a keyway and I gotta assemble a key. If you have those types of features, then these are useful. Every time I assemble this, I mean, you could have made a subassembly here. This could have been a subassembly, and you just drop the subassembly in. That's one way to do it. But some of these SD bushings, they're mounted from the other side with tap holes, and you don't always want all that information along with it.
Yeah. All right. Well, so we build SLUGME to go until 9 Eastern. It's we're already 27 minutes over, but I've got a couple. I think we can do some rapid fire questions here.
Okay, what do you got?
Yeah, let's see what the panel can weigh in on here. I'm not going to share my screen to show the question, but the question is it a good idea to keep your toolbox location in your PDM vault?
You're asking the wrong guy.
All right.
Eric, that's you. I mean, you use PDM in practice, obviously. I don't use PDM in practice. So for me to make that kind of statement, it's, I'd rather not take that one. I'd rather yield to people who use it in the real world and not make a demo.
As long as you're not sharing native assemblies to outside people that don't have access and you're doing it the worst way possible, then yeah, put it in there. Make sure everyone in your organization has it.
Right. If you're not in a situation where you're going to be sharing anything outside,
it's certainly useful to put it in a common, even if you're not in PDM and you're on the network drive, it's good to put it in a common network location so that everybody's pointing to the same toolbox. So that, I mean, you may have certain standards. I don't want people buying, a socket head cap screw every 1/8 inch size. I want them to only use, certain sizes that are available. So you only make those available, and you do that with the configuration tool to only make those available. So
make the upfront investment to actually set it up right.
Yeah.
Yeah, exactly. Yeah, so sorry that's not a super clear answer to your question. However, it's a good question, but it's very case specific. So yes, it can be a good idea, but it's not always a good idea. All right, let's move on to another one. All right, so when using fully defined sketch from the drop-down menu, it sometimes indicates that the sketch is not yet fully defined. What's the best way to fix this? I've noticed that too, and sometimes it needs you to anchor like one sketch feature.
Right, and if you just draw, if I would create a new, I know if I just create a new part and use fully defined sketch and put in a couple circles, like Cam said, it's always a good idea to anchor it to, something. But, in this case here, if I don't have anything anchored and I use fully defined sketch, it's still going to choose that origin. It kind of does that kind of automatically. So this is a simple case. Usually if you have things that are sketches that are so complicated that it struggles in understanding the sketch and how you really want to define it, might leave some things underdefined, but you don't want to have your sketches overly complicated, but you want to capture good design intent in your sketches, no doubt. I've not seen too many situations where that is. Maybe you've run into that.
I have run into it in the past, but I can't off the top of my head remember what situation that was. But yeah, I do remember getting
the other thing too,
a message or an error that said what I needed to do to fix it was that there possibly just needed to be an anchor to origin somewhere, and then
just like you said, something anchored to the origin, or you can define where you want that to go. But also, if you turn off one of these, if you don't have one of these on or off, it doesn't know to build relationships, then it usually can't find it. You can also turn, control which ones of these you want. If you don't want to have any perpendicular relationships, you wanted to, always do horizontal, vertical, and dimensional stuff. You can do that as well. I have seen that, but
I just saw something that I wanted to show. I'm gonna share my screen here.
Yeah.
Share the application. SolidWorks. All right. So this was a model I just modeled for Model Monday Live last night. Toby Schnars, you should check out his YouTube channel. I just deleted all these dimensions to do this real quick. And I don't know if anybody else uses dark mode the way I do. Of course, I'm not in 2021 yet where it's true dark mode, but up until and through 2020, you can change your layout to be darker, and I changed my background as well. But right here, it looks like I don't have the drop downs available to even edit these relations and dimensions option. Don't let it fool you.
your bottom line down there. If you uncheck relations there,
it's there.
Oh, it's there.
Can't see it because it's dark mode.
Wow.
I just saw that and I was like, what happened?
Time to call the UX guys.
Yeah. They're there. Not to worry. Yeah. So sometimes I like to deselect some of these because it will like really overcomplicate when you use too many relations.
Absolutely.
Yeah. So you might have things that are accidentally the same length, and if it notices that they are the same length, it will force them to stay the same length because you have equal relation on there, and it just went, oh, they're both the same. Well, obviously that's what he wanted. So, and it does that for like collinear as well. You might not want them to be collinear, but because they already are when you hit the button, they will remain that way forever. So, all right. I think I got one more here. This should be a fairly quick and easy one, and then we'll wrap it up. Earlier tonight during Ed's presentation, he was talking about renaming hotkeys. It says, I reassigned my F2 command a long time ago, so I have to go in and find the rename command in the customize menu. Does anybody know that rename command?
There is no rename command. F2 is a Windows command.
Okay.
So you just have to unassign whatever you made F2.
I see.
So if you like highlight a file in Windows Explorer and hit F2, it'll start renaming that.
It's in Tools Options Feature Manager, Cam. It's about the 6th, 7th one down. Allow component files to be renamed in there. But if you change the hotkey,
right.
That's what he's saying. Yeah, just go into your customization and undo whatever you have F2.
I'm in there. It's just not showing you. Oh, there it is. You are seeing it. Gotcha. Yeah. Allow component files to be renamed from feature manager tree. I definitely use this. I don't know why it's off. Oh, that's because I reset for my presentation the other week. But yeah, that's a very, very handy. So the way when you do that, did Ed explain that when you rename something, it's not going to actually rename it until you save?
if you rename a component, that is correct. When you hit save, it'll give you that dialog.
Yeah. Yeah. So if you're in an assembly and you come over here and rename it, not obviously this is a feature in a part, but if you rename it here, it actually won't rename the part within the assembly until you save. So you can lose those if you don't save after.
So Cam, if you go to your tools option or customize your toolbar, and go to keyboard, and then this second one under show, say show only commands with keyboard shortcuts. Second one there. Okay. And then scroll down, you'll find the rename in there.
Oh.
It's called Feature Manager Tree Area. Do a search. Oh, you can't do a search in there. So yes, just type Feature Manager Tree Area. There it is.
9.
Mine is F9. Oh, no, wait, I redefined mine.
Yeah, because F2 is a Windows thing. It's probably not in there.
Right.
You just have to find whatever. If you
No,
made
you know
something
what?
else.
F9 just collapses the feature manager. I'm wrong on that.
All good. So if you unassign F2, well, you can't assign F2. Is that what we're saying?
I think
You can assign F2, and it'll overwrite the Windows command. So you'll have to unassign it in SolidWorks.
You unassign F2, it should get your Windows command back.
That's what I'm thinking.
Gotcha. Okay. Gotcha. All right. Let's see. Do I have anything else? That's all I've got. We have had quite a few questions rolling in, and I apologize we're not going to get around to everything, but this has been a really good SLUGME and a good Stump the Chumps. Mark, thank you very much for coming in and saving our bacon.
Thanks for calling me.
Oh, for sure.
Yeah.
I was on listening to the rest of the SLUGME and was already in the meeting. So.
Oh, nice.
Present.
Just hiding in the back row, huh?
Hiding in the background.
Fantastic.
Totally random.
Right.
Dan, are you going to use smart components now?
I'd love to. If we made the same thing twice ever, then yes.
Oh yeah, if you're not doing that, then they're probably not very useful.
Yeah. No, I think I'll find some opportunities for sure.
Oh, definitely.
Yeah, and I want to let everyone know that the chumps get together every month or so to do this kind of open-ended presentation and Q&A session, and join us next time, everybody.
Yeah, it's really fun because if questions come up randomly throughout, or somebody will come up with an idea, and everybody's sitting at their own computer doing, trying their stuff and sharing ideas with each other. We share the screen back and forth like this, and yeah, it's really good time. So
yeah, we might have one or two questions kind of lined up, but it seems like every question that we have queued up spawns 2, 3, or 4 more. So it's totally free form, and it's fun as fun can be.
Yep. So watch the SolidWorks forums for announcements for the next Stump the Chumps. Also, we're all on Twitter. You'll see it there too. So, all right. Well, I'm going to go ahead and do one more plug for SWGN. If you're not a part of a user group, please find one and join it. SWGN.org. You go there and search for a group. It will take you to your closest group's meetup.com page. You can join that meetup group, and they will send you automatic notifications anytime they have the next event lined up. So please do that. If you want to start a group, go to that same website and get started. You can also email usergroups@3ds.com or us at sw.slugme@gmail.com, and we can help too. So that is it. I would like to say thank you for all the people who are helping us behind the scenes. You guys might not notice them, but there are a bunch of people up back there, along with these chumps, who have been answering questions all night and helping with the logistics of this. This is a big thing to pull off, and I thank you very much, everybody who's involved. All right. And as that, I will say thank you and good night, and we will see you next year.
If not sooner.
That's right.
5.5.
Right on.
V.VB. All right, everybody. Good night.
Later.
Good night, John Boy. Good night, Cam. Good night, Todd. Good night, Dan. Good night, Mark.
I just had to let you do it.
Yeah. It's my signature move.